we pass by Orion, making our way to the great pillars of creation. Stardust is not just stardust up here. It is magical. Can you feel it?
All right, what's up, hackers? Welcome to Chill Code. My name is Taggart, and joining us for his first guest appearance is, if I can get the audio set up, is Husky. Say hello, Husky.
Oh, it's HuskyHacks here for the crown.
Yeah,
all hail the crown.
Nice.
Thanks for having me, man. It's really cool to be here, and I'm here for what might be, the topic that has been interesting me the most lately. Which
my
is
pleasure.
Writing Nim.
My pleasure indeed. And all right, so we're gonna start with some basics tonight, and just to set some expectations. We're gonna go over basics on Nim. We've done a little bit of that before, but we're gonna go over them again. We're gonna start by making a real basic reverse shell. And then we're going to move on to something that I've been playing with, which is, making things like Meterpreter relevant again, because for those of you who can't afford a Cobalt Strike license and don't like Covenant for one reason or another, I know, Husky, you're working on Merlin, and that's cool.
Yep.
But, like, for those of us who kind of just want to do demonstrations of things, especially if we're doing, real basic adversary emulation or just testing out our tools, can you get well-known C2 frameworks past defenses? And so we're going to do some of that, and then we're going to move over to Husky's current opus, which is DNS exfiltration. Husky, do you want to talk a little bit about what DNS exfiltration is?
So I guess I'll start by saying that, like, they say what's old is new again, right? And I'm finding that a lot of my lines of research lately have been taking concepts like how in the past have people gotten information from inside of a network out to the external network or wherever they want to drop it to. And I'm finding that Nim has been like a really nice facilitator in my lines of research of getting tools that used to be completely burned, like things that you'd never even expect to work again, bringing them back to life, right? Which is super interesting. So, in the context of DNS exfiltration, you and I and everyone in the world needs to have like these central servers called DNS servers that basically say, hey, if you have an IP address for your website and you don't want the rest of the world remembering your IP address by its IP address, I'm going to go ahead and assign a name to it, right?
Mm-hmm.
And the servers keep track of that, and I'm sure everybody's kind of familiar with the DNS method, right? Of you say, hey, where is google.com? And the DNS server says, oh, I got you. Or it says, I don't know who that is, but I'll ask my other DNS server that's over here. So DNS exfiltration is an interesting take on this process, because you can there are a couple different types of DNS records, right? And so the one that concerns DNS exfiltration is the text record, TXT.
Mm-hmm.
So effectively, you can send a text record to a DNS server with the first part of it, or really any part of it, but usually it's going to be the first part of it. You know how the DNS kind of works. Subdomain is the first part, www dot, middle domain, Google dot, and then top level domain.com. So the text record can be sent with the first part, the subdomain, as any arbitrary amount of data. And it has to kind of follow along certain guidelines, and we can actually get into that when we're structuring how to actually build this thing. But you can fit a surprising amount of data into a text record and send it to a DNS server. So there's kind of two ways to do this. The one method that I've been doing is basically cutting out the middleman and sending the text record with an arbitrary block of information at the front,
mm-hmm.
right to your exfiltrating server. So basically pretending, like telling the DNS exfiltrator tool to just go look at that DNS server, and it drops it right onto the server that you want. So technicals aside, it's just a way to tunnel information from inside of a network outside of a network with DNS queries and DNS text records as the vessel of information. So it's super interesting, and I've been told anecdotally that in pen testing and red teaming, if DNS exfil is a good thing to start with to kind of baseline like what the environment is picking up. Because if they can't really pick up DNS exfil, you've got to kind of beef up your network defenses, and you can kind of go from there. So that's just a little bit about the background there.
Thank you. Yeah. So like, from a defender's perspective, here are a couple of things that I think about with DNS exfil and why it keeps me up at night. So in order to log DNS effectively, you really do have to have all your ducks in a row.
Yep.
With a security architecture, because DNS, I think of it kind of as a little bit separate from other technologies that we think about, just because of the scope, the scale, and the integral nature of it to the way that all networking takes place. Mm-hmm. But put another way, you are going to generate, even in a moderately sized environment, tens of millions of DNS events every day.
Yep. It's a huge, the problem of tracking that data down in a scaled enterprise environment is insane.
Right.
And so like a lot of the kind of tools to try to pick up on that stuff, you're going to want to look at a lot of your data visualization things, like when you pull data into something like Elastic, and then you go to Kibana and you say, okay, let's bucket like host by time by DNS query. And usually that'll give you a good baseline. And then if there's DNS exfil or DNS C2 is kind of, think DNS C2 effectively DNS exfilling, but to return the information coming off of the C2 agent. So pretty much a very similar idea. That kind of traffic is going to spike like crazy. Yep. for a DNS exfil and C2.
A few things that we've put together that are revealing. So first thing you want to do is, and this is just baseline, because one of the things you'll see really, really simply, forget the text record, you can even see DNS C2. Oh, by the way, Bo Knows Tech, thank you so much for the follow. But one of the things you'll see is like base64 encoded chunks of data as the subdomain, right? You can see that even in this example here.
Yep.
And what you
I'm laughing because that's exactly what I did in my
right
my implementation.
And so, by the way, tools like Rita are really good at capturing this. If you have packet capture, right? They're specifically designed to look for beaconing just like this. Now, that being said, not everybody has Rita. Not everybody has that kind of visibility. So, a few things you can do even in your run-of-the-mill sim is if you have DNS logging coming in, you can start looking for abnormally large DNS domains. And you're going to get, at first, a lot of false positives with that because there are a lot of legit services. Sophos we'll talk about like as one of them, but like that have really large domains. But then if you have your kind of known goods, if you have that in a lookup table or something like that in Splunk, and you can filter those out, now you have like a reasonable baseline to start looking for something that is weird. And that's just for the size of the subdomain. Another thing that you can look for is the size of the DNS request itself. Attackers can use, UDP 53 or TCP 53 for their traffic, but DNS requests pretty much all have the same size, around 50, like a couple of 50 bytes or something like that.
Well within a very well defined from the RFC. It's got a very well structured, well defined data parameter, right? So as soon as you start to see the long trailing base 64 going on and on and on and then stopping, and then the middle domain coming up, it's like, okay, yeah.
So you can hunt that, and there are a few other tricks for beaconing as well. I have a really interesting visualization in Splunk that will produce a beaconing probability chart with variance as the x-axis and count as the y-axis. It takes a while to render, but it's worth it because you'll start to see your norms and be able to move off from there. But okay, so we're going to get to DNS exfil, but let's start doing, basic evil in Nim, and we're going to start with just a simple reverse shell. So so what I have here is I just have my nimrs.nim set up here, and I'm kind of working off of the reverse shell that I did in F#, which no one liked, but I like it a lot because it's never caught, because no one knows what to do with F#. So the basic thing, what we want to do with pretty much any reverse shell is we're going to, with a reverse shell, remember, we are connecting to a listening server that we control, right? So our target is the client and we are the server. So the first thing we need to do is establish that network connection, which we're going to do with sockets. And then we are going to send some information, right? Basically, we're going to send a prompt to our server, and then we're going to listen for the command from the server, right? Once we have that connection established, then we're going to use whatever is sent to run the command locally on the machine. And there are a number of ways to do that. We'll do that pretty simply. Capture the output and send it back over that same socket connection. Is that about right?
Yeah, that's spot on. I think you're going to find that the send and receive socket methods here are gonna they do like in most libraries that when you're building like a reverse shell or a bind shell, the send receive is going to do most of the heavy lifting here. You might be totally shocked to see how easy this is going to be. I want to see, we were talking about this before. I want to see how Taggart does the implementation, because I just dug through, for those of you in the audience who don't know this, I'm writing a course on malware reverse engineering right now. And so in order to write a course on that, you have to kind of have the binaries, and I'm including a bunch that I caught out in the wild, but also the rest, and I'd say most of the course is custom written malware that I wrote to be instructional, educational, and emulate real life, right? So I just dug through my repo and I found my reverse shell in Nim that I wrote for this. So I'm looking at my implementation. So let's see what Taggart comes up with. Cause
awesome. Yeah. Okay. No pressure whatsoever. So I want to start with, so the socket stuff, I have a sense of how that's going to go, because socket libraries, whether it's in Python or Rust, that one was probably the hardest one I've ever done.
Yep.
Just because there's so many weird details, especially when you're doing it with an asynchronous library like Tokyo. But
right.
Okay, so the first thing I want to do is kind of just get like the the IO going. Hey Tater, good to see you. So I'm gonna start here down at the run command, and we're gonna just say exactly like this, right? Yeah, let's say output equals exec process. Thank you very much, IntelliSense. And we're gonna say, now what I want to see happen is if we can do PowerShell.exe nop window style hidden and C, and then just kind of like, who am I? We're gonna see what happens here. Now the way that exec process is written, it looks like I should have PowerShell.exe, and then the rest of this should be in an argument sequence.
So exec process doesn't even, you don't even need to specify, like you can have it be one, you don't have to break it up into arguments.
Okay.
by what I can tell. I mean, that's probably the correct way to do it. but yeah, it can actually just be like that. I think that should get you. I think you get the return value from that as well.
Well, let's look at the signature. So
Yeah.
it returns a tainted string, which suggests yes. And we will confirm it
Sweet.
just by like echoing the output. It's been like a couple weeks since I actually wrote any Nim code, so I might mess up some. What is it? And, right, for concatenation?
So yeah, you would do your ampersand. Yeah.
That messes with me so hard because I'm so used to ampersand being the bitwise operator.
Right, and I keep adding pluses in, and it keeps yelling at me, and I'm like, I'm sorry, I keep going back and forth between you and Python. I know I got to choose one. No, that's not true. You don't have to choose one.
No, you don't. Okay, so let's just see if this fires off.
Let's see that, and then next step would be to just concatenate that with an input that I specify, right? And then you've got your command executor, and then you just hook up a socket to that, and we're off to the races, my friend.
Now, a couple of things that actually just happened here that I want to shout out. So I'm building this in WSL because you can't make me, unless I'm kicking and screaming, develop software in Windows. I don't like doing it. There are so many weird things that happen, especially with pathing. I don't know, it sucks. So I use WSL instead. However, I was able, because this is WSL, to run PowerShell.exe. And I was able to run that even from within WSL, and that's why I got this. Now, notice that if I can run PowerShell.exe inside of my WSL session,
Yep.
This actually made the news way late last week. There was some report from some research firm that was like, attackers are, abusing WSL and hiding their processes inside them. And, people who have been using WSL for a while were like, yeah, and? That's not news. WSL has obscured the process tree for some time. And WSL2 is a straight up VM. So this is a known technique to use virtual machines to obscure what you're doing. I think it was the Ryuk ransomware group that basically was loading up with Hyper-V or whatever you had, but Hyper-V was their target, loading up a Windows XP virtual machine, mounting the file system within the VM, doing all of their encryption within the VM, so the host operating system never saw it happen, and then all of a sudden the files just were encrypted.
New tech.
Yeah.
New tech.
So
That's
with
nuts.
WSL, what you get is a virtual machine that's pre-installed and has all these capabilities. Now, it doesn't quite have, you can elevate to root in WSL, but that doesn't mean you have root, quote-unquote, on the Windows file system. I can't go after the system or SAM files. But it's still really...
I've gotten full reverse shells out of WSL. I've gotten Merlin agents. I've gotten... I want to say one either Meterpreter or a straight socket reverse shell did not work. One or the other, I forget which one. But I remember that one of them worked and one of them didn't. So yeah, it's Well, if you find WSL enabled on a target system and you're red teaming against it, it's a nice little ace in the hole to just kind of like hide stuff in if you want to, you know, just hang out for a second.
For sure. Now, okay, I want to do this the right way. The right way being, I believe that there is the format string inside.
You got format, and you're doing it the way that I keep telling myself I'm gonna do it and never do it.
But oh wait a second. This isn't totally right though, because I believe in order to use the format string syntax, I have to import string utils.
String utils, yep. And it's FMT, I believe. At the start.
Let's find out. I'm pretty sure.
Yeah. Let's look that up.
This is where my photographic memory does come in handy.
If you're wondering what the heck we're talking about, so string formatting is a nifty little tool. You can use it in a lot of different languages, but Python and Nim, like we're seeing right now, it's particularly useful. You can just throw a value into a place in like the string prior to where you're writing it. So in other words, you can just say, okay, PowerShell.exe, nop w hidden c, and then you throw a token there, like a little placeholder, and you'll say, oh, and then format that with the command, so just the variable command. So you don't have to like put that in the string anywhere. You can just kind of hold it, and then when the command is when the variable of command is decided, whether that's by input or by something else, it'll throw that right into where the token was sitting. So it's a nice little syntactic sugar, I think they call it.
Yep.
Is that the correct use of that? Syntactical sugar?
Yep. Anytime there is a shortcut that isn't actually what's happening in the back end, we call it syntactic sugar. And you were also, by the way, right on the money. It's a stir format that we need to import, and it is FMT that we prepend the string with. And then if we do that, we can just put in the expression in curlies, and that allows us to... This is better than string concatenation. And quick, like, programming hygiene aside, why is that true? Anytime you can write an expression that has fewer things that are like entry points for mistakes, that's what you want to do. And that's why I love format strings for this. You'll even see me when I'm writing JavaScript, I'll use string templates, because you can do that now without instead of doing string concatenation. Okay, so we have this. I'm also, just for line length, gonna see if I can get away with that. Yes, wonderful. Chad, good to see you. Okay.
Oh, hey, Chad.
So we have the commands set up here, so now we have to do the networking stuff.
Right. So there's an app for that. There's a library for this.
Mm-hmm.
There is a library for this. Import net.
Yep.
And oh, you've already got it. Look at that. And yeah, this is going to be your working library for all of the kind of socket open, socket close, socket receive, socket send shenanigans, right?
Yep.
So yeah, let's see what we got. Yep.
So normal stuff, we're going to set up port and address. This is the kind of stuff like when you download this thing from exploit.db, or, you know, even if you were going to do this like inside of a Metasploit module or something like that, the kind of stuff that you want to change when you're creating your payload. Now, with Nim, remember that this is a compiled language, so you want to change this before you compile it, because you're going to get the exe, or you're going to get, if you do this so far, we could do some conditionals to make this work on Linux too. Use a different exec process, but yeah. Chad, I'm glad that you're happy to see Husky here. Not to give away too much, but it turns out that Husky's going to be back with us on Saturday, and we're going to be doing some malware analysis. I'm super hyped for that as well.
Yeah, man. So yeah, I'm combing through the maldev repo to find the good sample. We already talked about the one that I think we're going to use, but there's so many in here. But I think I'm going to use that one. It's a fun one. Yeah. I think it's one of the challenge binaries. I think you're up to it though. I think you're up for the challenge. Especially given that you'll have the author of the malware with you.
That is a bit of an assist.
I've been told that malware analysis is much easier when you have the author sitting in the room and you can be like, well, what were you thinking when you wrote that part? And he's, oh, that's
It's never happened to me.
That's an
So
array. That's an array to put the URL string together so it's hidden out of the thing. Yeah, yeah. It's much easier when they are just there to tell you that.
that's like, okay, now Sergey, why did you decide that you were going to split the string here and then? All right, so we got some more folks coming in. Destroy Worlds, good to see you. A hacker,
Hello.
what's up? Cinder Remedy. No, you're just getting started. Destroy Worlds, we're just getting started.
Yeah, we are cooking on an induction stove. We have just put the stove on. It's heating up. We're gonna give it about 20 seconds. I don't know where I'm going with this bit. Anyway,
Okay, so this is interesting. So basically, we're gonna do a socket. There's a new socket method that produces a new socket object. Okay. So we'll just do that. Sock equals new socket, and sock.connect, and we have our adder. And oh, interesting. So port is a class as well.
Yep.
Now, am I correct in assuming that this is kind of obfuscating the stuff that we usually see with like the AF-INET?
So AF-INET sock stream. So I think that's abstracting that away, and it's just like, and it will even do kind of like a some kind of like bounds check. That's not the right term for it, but basically like, oh, is this a port in the well-known port range? And like the port class will not accept it if it's not. So it works out pretty well. Yeah.
Well, let's see if that has any issues for us if we're choosing an arbitrary port here like this, like quad 9s. We're not going to be doing
okay.
SSL. By the way, what they really mean is TLS, unless they're really using SSL. Don't do that, by the way. If you use SSL instead of TLS, you're going to get caught. Okay, so we're not doing UDP. See, yeah, you can do this explicitly. By the way, there are folks in the chat who probably have, if they've ever started to play with networking libraries, they've probably seen some of these things. And they're
Sock
like,
AF, bro.
Yeah, and what's
that
going
socket
on
is
here?
Sock AF. Oh god, here we go. Okay, break out the documentation because Husky is about to get this wrong. AF-INET is the scheme of transportation, so I think that's
It means IP4.
IPv4, right? What is it? AF-INET sock stream is TCP or UDP, and then what's the last one? There's 3 in there. AF-INET, sock stream, and
Sock dgram is UDP.
Oh yeah, well yeah, that would be UDP. Yeah, it's the parameters you pass in to say what type of network communication you're using and how, if is it stateful or stateless, UDP or TCP, that kind of stuff.
And
go ahead.
well, I was gonna say, actually, do I want the IS? No, I don't. I want the TCP IP model to demonstrate this. So what we're really saying to the socket is the socket has a bunch of different ways of decoding the packets. Remember, we're just talking about raw packets at this point, and a socket is a FIFO. It's basically just a file that's represented somewhere on the machine that has data going into it and going out of it. That's what's happening with a socket. It's really cool when because you can make those manually in Linux, and it's really, really fun to play with those, but that's really what a socket is. Now, here's the thing. That's where the data goes, but then after that, this library has to understand how to interpret it, how to take that packet of data and peel back the layers, right? Because remember, everything is encapsulated when it's sent over network protocols. And what we want to do here is understand, how is this thing encapsulated? We're not really an application at this point because we're not talking about HTTP or anything, but we are absolutely talking about transport encapsulation, and we are talking about network encapsulation. And because of that, what we're defining with those values in that socket call is telling the library, like, this is what you're going to use in the back end to decode the traffic that's coming into this socket, and how you're going to encode the traffic going into the socket. That sounds something like right?
Yeah.
All right.
No, nailed it. I was just thinking, I'm parsing through like, oh, it's just a file. Like, I never even thought that it's just like a file representation in the OS somewhere.
Yeah.
But I guess that's how like name pipes work. It's kind of the same way, which is it gets a little in the weeds, but
I mean, the command mk FIFO, right, is exactly what's going on here.
Yep, there we go.
Okay, so
Nice.
we're creating the socket, and we're not creating a server in this case. Because we're creating, we're going to bind or connect to a server.
Getting a call back. So
yes, actually,
but if you were doing a bind shell, which I'm looking at my other one here, yeah, you would set up the bind server to open up the port to be the bound socket.
Now let me ask you this, as a professional pen tester and not somebody who does threat emulation as a blue teamer full time, how often are you using bind shells as opposed to reverse shells in real engagements?
One, I would say that you saying I'm a professional is very generous. But two, reverse shells all the way.
Yeah.
Bind shells have limited use if you're in deep behind enemy lines, I would say. But in your general day-to-day usage, your reverse shell is going to get you a lot more mileage. And the reason is because between you and the rest of the world usually exists one, if not several firewalls or network boundaries or things that you can't traverse. So if, let's say I get somebody in some other location on Earth to open up my payload, and it's a bind shell, it opens up a listening port on their machine. Great, awesome. How am I going to get to that? What am I going to do? Like port forward through my router and then hope that there's no firewall in between there, and then hope what am I going to be like? That's insane to think about. Reverse shell is going to have their machine go, oh, there's an IP address at this weird IP right here. Why don't you just go connect to that and see what happens? Boom, and then it just happens. So yeah, it's reverse shells all the way. Bind shells have use when you're on the internal network, but that's like, yeah, it's I wouldn't even say it's 80-20. It's like 95-5.
And in part, it's because of the path of least resistance for network engineers, meaning that of course, host-based firewalls have to be configured to protect against arbitrary inbound traffic. Whereas, who freaking knows what a user's going to do and what they're going to try to connect to outbound? And for that reason, outbound firewall rules, if they exist at all, are extraordinarily permissive. Very,
very permissive. Yeah, like quad zero allow kind of permissive, like all port allow most of the time. So
am I looking at this correctly?
If you want to, what are you?
Finish your thought.
My thought was, if you want a really good practical example of how permissive outbound firewalls can be, go spin up an AWS EC2 instance. Just go do that and see what the default, how you can configure your security for the inbound, which is locked down all to hell, and how you can configure it for the outbound, which usually is just like, now you're good. You could go do whatever you want.
I mean, you can do some crazy stuff with security groups, but they definitely make it much more intuitive to control what's coming in. And in fact, there are some a priori safeties that you're prevented from allowing in. You have to flip open the protective shell for the button before you let certain things in. All right.
Exactly.
So
anyway,
so send. Am I looking at this right? That there's just this send function that will take a socket, the data, and then it just goes.
Yeah. Sock.send. And then your method argument is I mean, mine is output, which is the what is my output here? Let output equal exec it's literally output equals exec process whatever you pass into the command.
Well,
and
so
then
what I
you
want to
can
do
sock send output.
Yeah, I think so. What we're gonna need eventually is an infinite loop here. We haven't done it yet.
Yes, you will need like a while true.
Yeah, but for now, let's say
you do need your socket connect host, which it looks like you've got, and then that's pretty much where I entered the while true.
Yeah, so the way that I'm going to do this is create kind of a nice little prompt here for my
very nice
for my user, and then that's what I'm going to send first. So and this is because if you've ever done, not if you've ever done, that when you do a netcat return, you'll get it's not clear immediately whether you've gotten a connection. It'll say connection, but are bytes actually coming in? This lets you know right away that you're getting data coming in. So we'll send I might want to reorder this a little bit. Yeah, there we go. Prompts, and then send my prompts. See, I like to plan with comments before I write code. It really keeps me on track.
Mm-hmm. Yep. I'll begin with the end in mind is what I always try to say. Like, just grid out the functions of what you're, not functions because that's a loaded term in a programming sense, but like grid out the things that you want this thing to do, and then just like write to those in each of those areas and try to keep it as modular as possible.
So you know that I'm by nature a functional programmer.
Oh yeah, for sure.
And one of the things when I'm teaching new programmers how to write functions, the first thing I tell them is write the function signature first. Like, and I refer to it as like calling your shot, like Babe Ruth style, right? Or on the pool table, where you want to say, all right, this is the data coming in. I'm going to say, I know for sure that I'm going to return this thing, whatever this data type, whatever it is. And then all you have to do is implement it. But you don't have to guess about what the function is doing because you've already described the shape of it.
Yeah.
All right, so we're sending to our socket. What are we sending to our socket? In this case, we're going to send our prompt. And do we need any flags? I think we're going to be good by the default. It seems,
I don't have the method signature in front of me, but it seems like, that should be fine, what you've got there.
So I don't even have to receive, I don't even have to like flush my socket. It does that for me?
No, it does that for you. You do have to receive at some point. Let me...
Yeah, right here.
Well...
You do have to receive, but you don't have to flush the socket. This is freaking easy mode, man.
I know, man.
Why? Like, I wonder... Okay, here's the thing that keeps bothering me with Nim, right? It's too easy. Every time it's like, what price am I paying for this? Yeah. And so far,
and you're like, oh, it must be an overhead thing. This must be so slow. No. Okay. I mean, is it dangerous? Am I writing unsafe? No. Okay. I've sold my soul then, I guess.
I don't know.
Yeah, you sold your soul for the crown.
We suffered long enough. That's right. I have to embrace monarchy is what it is. But you know what? The Constitution, I think we've had it. Destroy worlds, Haskell types. I love Haskell, like deeply and profoundly, and I think it's an important language for people who want to become, who want to really level up their programming discipline. I think Haskell is a great language to do it. I can't imagine writing full-out enterprise-level applications in it. I know some people do, and they're astounding to me. But the Haskell type system teaches you about how to new ways to think about programs, as does the Haskell pattern of recursion in lieu of iteration. Okay, so let's receive some data here. What do you think? Receive line?
Let me see.
I think just
So in my implementation, command equaled whatever was received from the socket via the receive line method with no parameters.
Okay.
Or no arguments.
Do you strip the line break, or does it contain the line break?
It may do that for you because I didn't have to strip line. I didn't have to strip white space, anything like that. I mean, it might not hurt, but
this is offensively simple. Like the amount of weird crap that you've had to do to create this sort of stuff in other languages.
Yeah, man.
All right, receive line from the socket. No flags. Just like, are you kidding me?
Yeah, you don't even need to specify sock in there, I don't think.
At least it looks like it doesn't, but maybe it gets registered some other way. But it does say Possibly. It takes a socket argument. Well, we'll see what happens.
Is this instantiated socket a class, and then it just has all of that like as an object?
So
maybe because I'm not passing in anything.
So weird to me is this is new socket. Actually, let's read new socket. That might clarify this a little bit.
Because I'm looking at this and I'm like, I don't pass anything to receive line. I don't pass anything to really much else.
Creates a new socket. The socket handle associated with the resulting socket will not be inheritable by child processes. I have a feeling that there's some automagic stuff. Oh, wait a second.
So those are the procedures.
Yeah, I have a feeling that there's some magic going on in the background where it's like it's going to register the default socket, even if you use that even if you don't specify. But I'm going to specify.
Yep.
Just in case. The function says it takes a socket argument. Now, let output, and then we're going to do send sock output, and then that's kind of it, right? We're going to do while true and colons, right? For our blocking.
Yeah, yep, just bump that. Yep, you're good. You're on the stream is like just about a half second behind.
I can
IRL,
share
so.
my screen to you over Discord.
Actually, yeah, sure. Let's go. It's just so I can think in real time with you while we do this, and I'll keep the chat open, but supplant this window with this window. There we go.
There you go.
Nice. Okay.
Okay. So, I think that's pretty much everything we need here for a reverse shell.
Yeah, let's fire this bad boy up, see what happens.
We're getting some errors here. Type mismatch.
Okay.
Oh, does adder
yeah, maybe that's like
adder had a meaning.
Yeah, I think it's a yep, there you go. You
Very funny. Okay. Then we'll do nim c.run. Actually, let me split my screen here. Okay, and we'll listen on 9999, and we'll run nimrs.
And would you look there,
oh,
ladies and gentlemen?
You love to see it.
Oh boy. Oh, we've created fire.
Okay, so that's.
I love how your calculator opens to the like trigonometric one. I'm like, that's that.
Okay, let me tell you why. There is actually backstory to it. This is why. This has been driving me crazy for actually a decade. Windows 10 has still not fixed the alignment between the equal sign, the decimal point, the plus, and the 3.
Oh my god.
It's not correct, and I'm sorry that now you know that, because you're going to have to live with it. It's like the FedEx arrow. You're going to see it.
It is the FedEx arrow, yeah. Oh god.
But much less pleasing. Gingerroot, good to see you, man.
Oh man. We have new technology, baby. Look at that. Reverse shell.
Okay, so
well, let's see. Oh, hold on. Before we, okay, you ran calc and it returned. Okay, so we're good. Like, at this point, like if I had just written this, I would have put in one command and it would have thrown an exception because I'm not good at this and it would just break everything. But it looks like yours is like repeating the loop and it's totally fine.
Well,
so.
Here's the thing though, like let's talk for a minute about all the stuff that Nim did for us that we would have had to do in other languages.
Oh man.
So one of the things is like the send and receive is just happening, and we don't have to specify a number of bytes. We don't have to specify an until. It's just kind of, it is setting up buffers for us, and handling it without us having to do anything. That is super, super handy, right? Because you can just focus on the logic. You don't have to worry about your memory management in any sense. Nim is doing that for you. In Rust, you absolutely, not only would you have had to create a receive buffer and a send buffer, but actually you would have had to combine them into a new struct.
Oof.
In order to use it with the same socket. Like, I hate doing this in Rust because it's so... I appreciate how much I learned about sockets because I had to do it, but having to do it constantly would be such a pain. So this is like, definitely, if you need to build something quickly, this would obviously be a first choice. And by the way, you mentioned performance. I don't think we said this on the stream. Nim performance is approaching C.
It's ridiculously fast.
So you're not paying a performance price for using it.
Mhm.
Destroy Worlds. I'm so glad that your follow along is working. It's really cool. I
Oh,
love this
we
feeling.
got our live studio audience is following along. That's so cool.
Yeah.
Awesome. Yeah, dude. Like, I am writing. I set out in the malware course to write a bunch of different types of malware, and like to an extent I have lots of different languages interpreted, compiled, but like when it comes down to it, when I want to get a proof of concept up and running so I can teach a concept for the malware course, it's been Nim like 9 out of 10 times, because I'm like, oh well, I could just get a quick reverse shell like up in this application, boom, there it is, and it's like 20 minutes later and I have a working proof of concept, and I'm like, okay, how can I expand this now? Every time I've wanted to teach something about like persistence, like writing itself to the registry, or writing to the startup directory or anything, the DNS exfil thing that we're going to see a little bit later, it's been ridiculously easy to put these things together in Nim. It's really concerning how easy it's been to put this stuff together in Nim. So yeah, I mean, I guess we got to live with that now.
Oh yeah. Well, what we're gonna do next, right? The next thing we're gonna do is we're going to create a interpreter payload, and one of the things that you have to do to make this work well, you don't have to, but the way that we're gonna do it, we're gonna base it on one of Marcello's samples, and
Nice.
we're going to create a remote thread.
Yes.
Right? We're going to inject shellcode into a target process. Now, here's the thing. In order to do that, right, we're talking about something that works on Windows. Creating remote threads is not really a thing in the Linux universe. That's a thing that happens in the Windows API. So in order to do it, you need to talk to the Windows API, which I really hate doing because the documentation is really tough to read and there's a lot of it, and some of it actually isn't documented on purpose. Now, if you look at some of the examples of doing this, there are C# examples that are pretty easy because .NET has some of this kind of built in for you. There are C examples if you want pain, and there are Rust examples which actually are worse, because what you do with Rust is you actually have to import the C interop library and use the C types in order to gain access to the Windows API. So it's like a nightmare from start to finish. What you're about to see is the easiest version of interacting with the Windows API I could possibly imagine. And it doesn't seem like it should work. OreoBite, is Nim whitespace sensitive? Yes, it is.
Yes, it is.
But only kind of. It's not.
Yeah.
It's not as whitespace sensitive as Python.
Yeah, it's quite forgiving.
But it does represent blocks of code with indentation. So I think that's kind of where I'd say it. But for example, it's totally good with this kind of nonsense, right? Where I indented the next line just because I wanted to have fewer columns in my line.
Yep. And usually it'll allow different amounts of indentation as long as you're held within kind of the same procedure or the same set of variables or something like that. Like you can double space in one set of variables and then tab in another one. And in the VS Code extension that we have that you guys see on screen, it will be very forgiving about the tabs. So it'll be like, okay, you're good with the tabs. If you're in like Vim, if you're nimming in Vim, good lord, if you're nimming in Vim, you can if you tab, it'll be like, hey, we don't use tabs around here. You got to use spaces. But in the VS Code one, which is the one that I code in, it'll be very forgiving about that. So it is white space sensitive, but it's not too bad. It's kind of it's easier to work with.
For sure. Okay, so the next thing we're going to do is I need to give proper credit. Marcello Salvati, also known as Byte Bleeder. You may know him as the author of Crack Map Exec or the C2 framework Silent Trinity. Also now the founder of Porchetta Industries, which is seeking to create a monetary compensation for developers of open source security tools. I really, really appreciate that he's done this. I'm a big fan of his. So
yeah,
one of the things that he's contributed to the community is the offensive Nim library.
What I like to call the sacred texts.
Yeah, for real. So the offensive Nim repository is a set of starters for learning how to create offensive security tools with the Nim programming language. So one of the ones that we're going to play with is shellcode bin. Pretty sure.
The classic.
Yep. This is our guy. Now we're gonna do this, and we're gonna write it to fail first because I want to prove that point, and then we're going to fix it so that it can protect itself. Now, in order to write this one, well, I guess I can write it on my host machine, but it's gonna get detected by Defender instantly.
Yeah, I would say probably.
So
you
also
probably have to kill Defender for that. Yeah.
Well, I have Nim set up on my Kali machine specifically for this.
You could, of course, just cross compile it.
Yep.
I guess, and just drop it right on your Flare guy as well.
That's right, and that's the plan.
Yep.
So
yeah, we need some shellcode first.
That's right. So what we're gonna do? Let's look at the example, and you can kind of see what's going on. So there's a lot to see here, but what's important is this function or process in. Oh, I did link the repo. And here's the link to the specific example that we're using. So you'll see here that it's starting a process, and that's how easy it is to start a process, and it's pulling that off of OSProc. And it's starting notepad.exe. Now you could put anything else you want in there. And I will tell you that you're probably going to want to not use notepad.exe, just because, no kidding, a lot of defensive tools and defensive like MSSPs are watching for specific executables doing weird crap. Notepad is one of them. So be aware of that. You wanna maybe start something like a browser.
I had this thought. Why does nobody inject into MS Paint? Is what I want to know.
Yeah, that's a great one.
That's what I want to know. Nobody ever does that.
But yeah, like firing up calc is gonna get you caught.
Yep. Same idea. Yep.
But so here's the thing. Look, it's suspending it, and then we're deferring a close. But then we gain a handle. This is the open process. This is where the Windows API stuff starts happening. And what we're doing is we're gaining access into the memory space of that process, and we're identifying it with its process ID. That's how the API works, right? That's one of the reasons we have process IDs in the first place. And then we're creating a virtual allocation of memory. And this right here, by the way, is something that good defensive techniques should detect on. But we're creating a memory space that is executable code. This is where our shellcode is going to live, and it's why you can see that it's the size of our shellcode, shellcode.len. Then comes our write process memory, where we write it to our handle. We send our shellcode wherever that is, and
then at this stage in the process, it's worth mentioning that the only thing that is nefarious or even suggests any kind of malfeasance is that page execute rewrite. That's the only thing right now that's like kind of sus, because everything else, if you the Windows API is and if it, like I learned what the Windows API was like a couple months ago. Like it's a very complicated thing, and you don't really think a lot about it. But it's when the people who put the OS together were working on it, they were basically like, okay, we want to make lots of the functions and the features of the OS available to lots of different people, and we don't want them to need to code at the level of the OS. So we don't need them to be down doing like assembly instructions, right? So let's create these well-defined maps of how to interact with certain features of the OS. And all you got to do is specify, hey, I want to use this feature, and you've got to send in the parameters that it's looking for just to be able to use it, right? So the OS is like doing these API calls all over the place all the time, right? Handles on processes all the time, allocations of memory all the time. The one thing right now that is a little suspicious is executable memory, which is like a little sus. The next thing we're about to do is like it's like the smoking gun. I like saying it's like trying to get through a metal detector with a bazooka in your trench coat. It's like it's the big one that's going to give it away is what you're about to see.
So a couple things. First, we have a couple of questions. OreoByte. First, how do you know if the Windows API is on or off? OreoByte. The Windows API is part of Windows. Accessing it is a thing you can do.
It's the fabric of it's woven into the fabric of the OS. It's these little things you can grab onto like that are all over the operating system. And as long as you specify what you want to do and give the correct parameters, and they have to be in the right data types that the parameters are looking for, you can use the Windows API for basically anything.
But to put a finer point on it, what we're really talking about when we talk about the Windows API, there are a couple of different dynamically linked libraries, or DLLs, that contain the functions that do the things that we want. What we're talking about here is either, depending on how the interop library is written, kernel32.dll or ntdll.dll. One of them is slightly higher level than the other, and that actually matters for the next thing I was going to mention, which is if you have good Windows logging, aka sysmon, configured correctly on a defending machine that's encountering this, there are a couple of other tells that will show up even at this point. Right, user32 as well, for the user space stuff. That's right, Gingerroot. So the first one I want to call out is image loaded, event ID 7. By loading up osproc and the Winim, the two libraries that we're using here, when we compile that for an exe, there's some DLLs that we load right off the bat, and if we have smart detections for that, the event ID 7 is going to see those first. The second is, even though we haven't created a remote thread yet, although stay tuned, we have access to process. Yeah. And that's what this open process was all about. If we have sysmon configured correctly, event ID 10 is going to trigger. Now, event ID 10 is not enabled by default because so many processes access so many others. This creates a whole bunch of noise. But if you have a clever defender who actually has this stuff set up and knows how to filter out the noise, this can show up. But it doesn't really matter because the next thing we're going to do is, as Husky said, the bazooka under the trench coat.
Yep, so at this point, we've allocated memory. We've stuffed our shellcode right into that executable memory, which is not backed up by a module on disk, mind you, which is also a little interesting to think about. And then what do we got for him?
So up next comes, once the process memory is written, we create a remote thread into our from our process handle, and that fires up the executable code that we put in that location. And then we're off to the races. That code executes and does whatever we want. The shape of that code is going to look the way that they've written it here, the way that Marcello's written it, as a bunch of hex bytes. Now this is the hex representation of the bytes in this MSF Venom payload Windows message box. It's very, very tiny. And you can see that the bytes are in order here. The way that we get it is MSF Venom P Windows message box F C#. I don't think MSF Venom yet has a format for Nim, but I'm sure it's on its way.
Yeah, it's probably on its way, and C# is the closest one that you can get. I find that it's just, and you can even, I wrote a little Python script to do this for me, to just like, it's just a couple quick little cuts, and then your C# shellcode is basically formatted right for the Nim array. In particular, the 0, excuse me, the 0x, and then the byte is the same between Nim and C#. So all you really need to do is prepend the byte that you see there, right? Yep, that one. and then the brackets on the outside, and basically you're good to go.
That's right. So we're going to create our own, because we don't want to create a message box. We want an interpreter session. We want to do the real thing. So we're going to, in our Kali machine, we're going to run MSF Venom. Actually, do I have 10.13.7? That's my try-hack me IP address.
You're 192.168.
That's my local home network. But what I have, and I need to set up is, my Kali machine should have. That was dumb. My Kali machine should have a second network adapter. It doesn't, so let me give it one. For my internal lab net. I must have rebuilt it or something. Add hardware.
So Oreobite, I saw your question. I'm now getting around to answering it. I apologize for the waiting. How do you know if your payloads are Windows ready? So like, if you're up against Windows, how do you know if your payloads are ready to go? My big piece of advice for red teamers is to build a lab that as closely mirrors your target network as you can possibly get it. And so you don't have to be one for one. In fact, you're never going to be one for one. But if you have any intel about the technology that's in use, the EDR and the antivirus that's in use, get those. Hopefully your company's going to pay for it, so they can be kind of expensive. Try to get those up and running, and then game against those and weaponeer against those. That's what I would say. You never really know. Like like on game day, you're never really sure if you're going to drop your payload and it's going to actually execute or get swatted by EDR. Like you just never know. You've got to be ready for that as a potential outcome, right?
Yep.
But that's kind of part of the fun, I guess.
And so is there any good way to modify Metasploit itself so Meterpreter functionally isn't caught, or is it better to modify another framework like Covenant or Cobalt Strike?
Meterpreter's so tough.
It's tough. We're going to do it a little bit today. That's actually what we're trying with this payload. But keep in mind that no matter how much you obscure the payload on the endpoint, and there's some stuff that you can, some stuff that you can't, especially against clever EDR. The network stuff, if it's not, over TLS, which you should be doing anyway, is going to give away the game. It is tough. You can put in the work. Actually, Joff Thayer from Black Hills has a course specifically on advanced C2 implant creation that goes over what you have to do to create Meterpreter payloads in C# and make them undetected. I haven't paid for that course, but I've taken like the free previews of it, and it's USDA choice. Strongly recommend.
Nice.
Okay, so what we're doing here from a lab perspective, by the way, is we're creating a closed loop network here. So I don't want my lab network to talk to the interwebs, so I'm creating an IP address for my Kali machine, 10.0.1.5, and I'm just going to temporarily add that to my ETH1 interface, which I just created. Dang it. IP add. No, it's IP add. APA add. There we go.
Yeah, IP adder add.
Dev ETH1.
Yep. ETH1
via
10.0.1. Or yeah, your address.
Boom.
There we go.
And now I have that IP address here. On my Flare machine, I know there's a PowerShell way to do this, but I can't remember it off the top of my head. So we're just going to do it the lame way. And we'll call that 10.0.1.4. I mean, sure, although it doesn't really matter. Okay, open network and internet settings. I get the weird Windows 10 new interface for this, as opposed to the old school control panel that makes me feel comfortable.
Oh God.
Oh yeah. This is our guy though, pretty sure. Yep.
Is it?
Yeah.
Oh, okay.
Ethernet 3. Manual. Yeah,
What is
trust
happening?
me. 10.0.1.
Don't like change.
Or yeah, no, I hear you. And by the way, could this be less clear? Subnet prefix length?
Subnet prefix length.
It's asking for the CIDR, but it won't tell you that.
Oh my god.
I'll give it a gateway.
You will need a gateway, I believe.
No. Oh, the problem was my IP address.
Oh, okay, yeah.
I won't need a
There
gateway
we
for
go.
this because they're
I
going to
guess
be.
yeah.
Just
No,
talking
you're
to
all
each
on the
other.
same. You're on the same network. Yeah.
But does it require a gateway? 10.0.1. Delicious. Okay.
Sure.
So now, just to prove that we've got this thing talking, I should be able to ping from my Flare machine. Take your time, PowerShell.
Yeah, PowerShell in Flare specifically is quite.
I don't know what they
slow
did
to
to
load.
it.
Yeah. Their little command shell replacement's not too bad.
Yeah. Okay.
Commander, the little lambda.
Yeah, that's
symbol.
nice.
Yeah, that's whatever.
Okay,
Yeah.
so we got an echo from 10.0.1.5, and we'll do it this way too. 10.0.1.4. Okay, so our two machines are talking to each other. That's gonna matter for our actual, attack. Okay, so with that then, let's go back to our... Oh, what was the Black Hills course again? I think they actually just came up with a new site for this stuff, anti-siphon training, right? Yes.
So Joff runs that one?
Yes.
Yeah, Joff's the man.
I should just look for C2, right? Yep, that's it. Enterprise attacker emulations and C2 implant development. I'll link that. You're welcome, Black Hills. By the way, I'm gonna be on the Black Hills 24-hour pre-show banter stream on the 15th.
Nice.
I don't know when yet, but they're bringing me on for half an hour to talk about stuff.
Ooh, man. Congratulations.
Cheers. Well,
Awesome.
By doing enough backdoors and breaches, they finally heard
Yeah,
what
there
was
you go.
going on.
You caught your big break, kid.
Yep.
All right,
I
let's
sold
go.
out to Black Hills.
Nah.
No,
this,
you can't. They're too legit to be a sellout. Okay, so we're gonna copy pasta most of this, but we're gonna modify it somewhat. And I'll put this in my. Did I make a new file called an interpreter? I didn't, but I will.
You
now.
made it over on Kali, maybe.
Yeah, I'm gonna edit it
Yeah.
here and just copy pasta it over so I have it in one place.
You got the syntax highlighting, yeah.
Yeah. I actually have syntax highlighting set up for Vim.
That's right, yeah, you set it up for Vim.
That's
so cool.
But
Vimnim.
yeah, that's one reason why I didn't want it to. Okay, so a couple of things that we're going to change here just to make this a little bit easier. The first is, for one thing, don't give your... I mean, the comments are going to show up, but don't give yourself anything... If you were really doing this as a payload, you want to get rid of any strings that could be
your
identifiers.
echoes. Yeah, get rid of your echoes. So as a nice little kind of bit of red team tradecraft here, anywhere that you would be inclined to use a sleep function, Windows Defender and EDRs in general do not like sleep functions if they're in the main thread. They don't like them. So instead, take a time measurement from the time when you want to sleep and X amount of seconds in the future and do arithmetic. Just mod some numbers. Generate a random number, mod it. Divide that number by another random number. Like just keep doing arithmetic, and then when the clock runs out, that's your sleep interval.
Yeah.
Yeah, don't use the OS sleep function. The EDRs don't like that.
Okay. So this is the part, right? What I got rid of was the conditional checking for 32 or 64-bit. We know that we're targeting a 64-bit system. Let's just leave that complication out of it. Now, though, we're going to have to replace this shellcode with the shellcode we actually want. So we're going to make it over in our Kali machine and move that over. So MSF Venom, we'll do P is Windows, x64, I can't type at all, interpreter reverse TCP. The format is not going to be executable. We're actually going to do C# just like the comment showed.
Yep.
We'll call it an interpreter.cs. And then here's where we change up the L host and the L port. So the L host is going to be 10.0.1.5, and the L port will be quad 9s. This was the 5, right? Got to keep those track. Yep, this was 5. So we're setting it to listen up here. While that's building, it won't take long, but while that's building, let's also fire up MSF console so that we have something to listen for this. Use exploit multi-handler, which by the way is like literally the only module I use for Metasploit at this point. And by the way, again, not really a professional pen tester, but at this point, like that's all I need because I have the payloads elsewhere and everything else I'm doing with other stuff, or just manually because the Metasploit modules either are going to get caught or they aren't as effective as they used to be.
There's a couple auxiliary modules that are really handy, but other than that, I agree. It's your mileage varies very well. You get limited mileage out of Metasploit these days, I would say. But yeah, some of the auxiliary scanners, and not like port scanners, but I mean like OWA logins, EWS, that kind of stuff is kind of what I've used it for.
I should amend that as well. You know, if we're talking about targeting a Windows system, that's definitely true. There are lots of legacy web apps that have plenty of cool modules in Metasploit that still work a treat. Oreo's asking, do you like to add command line options to your Nim or keep it without?
Command line options like for the compiler?
I think option flags, like you run it with an option.
Oh, like if I make a tool and like if I I mean, yeah, I've
exactly Ginger Tom. Yeah.
I mean, I also really like putting fun art and stuff, and then like arg parsing, and like I don't know, I love like being able to pass things into a program from the command line.
Absolutely.
So,
now for a payload, it's kind of a tell.
Yeah, exactly. If I'm writing it for a payload, I try not to. If you write it for a payload, you want it to be surgical. It like no extra strings, no usage. Compile it with certain flags to cut down on the line trace, the stack trace. Make sure it's super lean and mean. Yeah, no, definitely usage. If you guys want like a tiny little like AV evasion tip, and actually IPSec goes over this in his older video. It's still a really good video, but for methodology on AV evasion. But he's like, one of the first things that I do to evade AV, he's taking like raw Mimikatz, like right out the box. He's like, remove the usage and compile it for speed. And like those two things at the time of the recording of the video were all that was required. So yeah, it's remove usage, remove like ASCII art, that stuff, and compile it for either speed or size. Pick one, just make sure that you specify. Nim makes it super easy to compile for either of those. It's just a very simple, right from the compilation command line argument.
Yep. All right, so we're creating our shellcode here, and this is a much different size. It's 200,262 bytes as opposed to.
Yep. Can I make an aside here?
Yeah, go for it.
I have put in megabytes of shellcode into Nim wrappers at this point in my life. Like if you're not word wrapping, it goes off the screen and it just goes until sunrise, man. It's like, yeah, it's so like of that, and I won't say which ones because it's a bit of an OPSEC bluff. But some payloads, and if you know kind of the different languages and how they compile, like it doesn't take a lot of imagination to figure out which ones. Some of them are huge, right? So, and then you take something like Donut, which takes an executable payload and creates position-independent shellcode out of it, and that's even bigger. So, like, you're managing. I had to write like whole scripts to like rip the shellcode out of one file and put it into the other one. And then I needed to compile it on a physical machine that had a ton of memory, because if I was trying to compile it in on an EC2 instance or like a cloud VM, it just didn't even have enough memory. Like, it would just crash.
Now,
yeah.
A couple of things to note. I want to call out that I was able to copy pasta directly from Vim in my Kali machine over to VS Code. That's one of the reasons I like Hyper-V, because I have really good clipboard integration. Can you run Nim without compiling it when testing? Well, no, it still compiles.
Well, yeah. But yeah, you throw the -r flag in there, and it'll run it after it compiles.
And that's so important note, right? So Nim is a compiled language. It is not an interpreted language. And it's not even a bytecode language like Java. It compiles down to proper machines. So now I'm getting some syntax.
Yeah, did we miss
here.
you may need to bump your shellcode over. I think has it bled onto the. Okay, so yeah, see where your byte line is, and then oh god, we're in the wall of shellcode. You've got to bump that to be in line with the rest of the shellcode byte variable part of that. So yeah, just bump, and then maybe one more. Although just check at the top. Oh boy. I think one more should do it for you. And then save that and see if it still yells at you.
Yeah. The other reason I thought it might yell at me was just because it was too long and it stopped doing its thing.
Oh, your array size. Yeah, you're still 295 bytes, and it's like, excuse me.
There we go. Although it's still, I think this is about the size of the file. It's just like, I'm not IntelliSensing you. Go away.
Yeah, fair enough. IntelliSense, that's fine. We respect that. We didn't need to drop all this work on you.
So what we're gonna try here is we're gonna try to compile it. Now nim-c, nim-c, and then we're gonna run it with the D flag with ming-w. Now, if you want to do this in WSL or any Linux, you want to compile for Windows, this is necessary. You need to have the ming-w-w64 library. These are the headers and the libraries necessary to compile. I think it's like the C++ runtime. What you need to compile to get your application to run as an executable, a portable executable on Windows. So when I do this with nimterpreter, it should create a nimterpreter.exe. And what I expect will happen is that because WSL2 is not invisible to the file system, it'll get dinged by Defender on my host instantly.
Okay, let's check it out.
Oh,
you need to nimble install WinNim.
Nimble install WinNim. It's so easy. I can't deal.
Now one catch. Intel indentations.
There it is. There's your white space.
It's got to be that shell. Yeah, it's got to be the shell code. So 57. Okay. So one caveat. With that,
all of it should
be. The caveat to Nim's simplicity of installing packages and stuff like that, and this is a weird one. The installation candidate for like package managers is all out of whack across all of the distros. If you install the package manager version of Nim on Kali, it's a different version than the one on Ubuntu. It's a different version from even like a different distro that's built on Ubuntu. It's very, very strange. So try to use choose Nim. Hey, it worked.
Okay, so there's nimterpreter.exe. I can't believe it hasn't gotten caught already. But the second we try to, if we were to try to run it, it would get yeeted. So we're going to just real quick while we still have it. Maybe, let's see what happens. So I'm going to cp nimterpreter.exe over into WinHome downloads.
Okay, yeah.
And anything? Windows Defender. For shame.
So let me tell you, Nim wrappers for shellcode has been really, really effective for me lately. So
I've had this get flagged though, like verbatim. I don't know why it's not happening now.
Okay.
But no. It definitely is an effective. Even this is effective at getting past defenses. Now, I will say that other EDRs that I work with on a daily basis do catch this right away. And chat, I'm going to ask you, what are some things that this is going to get detected on? What are some things inside this that will get will trigger a detection? Here's our interpreter.exe. And let's get our Metasploit console up. All right, let's see if this thing works.
Big money.
Oh, wait, it won't because I forgot something real important. What'd I forget to do?
What did you forget to do?
I forgot to change the address in the source. Oh, wait, it's an interpreter. Just kidding. No,
yeah,
I don't
need
to do anything. I was thinking about the reverse shell.
No, you're good.
Restore. All right. The interpreter.
Big money.
All has right. Oh, hey, Al. We are using straight up this interpreter reverse TCP. It is not obfuscated whatsoever. It is straight up the shellcode. And
What do we got?
We didn't get a hit,
Mm-hmm.
but I wonder if it
Defender didn't complain.
Oh, I think I know why.
Just try from the command line.
Yeah. Ooh, it didn't fire at all.
Okay.
Still there. Hey, pause. What's going on? Let's try to run it here. Also nothing. Can you at least run payloads through threat check? You can do whatever you want with them.
Attempt to read from, no improper access violation, anything like that. Weird.
Well, wait a second. When
you're calling, hold on. How is your bump your main when is main module back one? I think.
Yeah, I think you're
you
right.
want to invoke that. You want to invoke that from like the very
yep
left. Yeah, let's try that.
The creator of Nim asked us very nicely not to write malware. This is research software.
So then your shellcode is you're a scoping. You've got like a scoping thing.
Yep.
In the past, I've just bumped shellcode all the way back to be
a global
a global variable.
Well, that's what's going to happen.
Yeah, I mean, why not?
It doesn't. I mean, from a detection standpoint, that doesn't matter.
Yeah, that's true. And a bump. And
I think
save.
Let's just see here. Echo running XC4 Volsher. Yes, I think we're good. So we're gonna rebuild that.
Yeah, this is like from a clean code standpoint, although none of this is
it's a mess.
Yeah. Not quite what you want to do, but we are we're always all right.
It's very large.
Yep.
Okay, so I'm still like really troubled by the fact that this isn't getting detected.
We're on Flare, right?
Actually, this is on my host.
Oh, okay.
And I'm moving it over to Flare. But by the way, like we can if we were to run this against like any run or Joe Sandbox or whatever, this thing's gonna get full lagged.
Yep.
So we're about to run it, Al. So we'll see what happens.
I'm thinking if this does not work again, we can break out like process hacker. Oh, I did see the flash of the command window there.
I did too. I think that one might have gotten up.
Hey, look at that. Now, you're Catherine Zeta-Jones, like, dipping through lasers right now. Like anything you do at this point from here on out is gonna risk you getting smacked.
Exactly. We'll fire up calc anyway, just because I'm a traditionalist.
Yeah, why not? Yeah. So in my experience, getting like a interpreter shell to spawn is usually not too bad.
Yeah.
Anything you do after that is like you're on your own, man. Like good luck. That's why Joff is putting that course together.
Yep, exactly. Now, the last thing I wanted to show with this, was, and Al, yeah, to your point. So when I ran this exact thing in my environment, I got dinged in Yocto seconds. But, and yes, Defender hates Interpreter will catch it in memory sometimes. But yes, if it's looking at weird process injection, right? This notepad.exe, like if we were to fire up process hacker on here and take a look at this, it would look super weird. And as I said, sysmon logging, if it's enabled for this, is absolutely going to catch this, right? You're going to see the chain we talked about. If we had everything set up, well, yeah, don't run get system. You don't have to. You have print nightmare now. But we would have seen some sus image loads as we loaded the DLLs that are required to make this happen. We would have seen, before even we got to create remote thread, we would have seen process access over to notepad.exe to create the memory space, right? And then we would have seen create remote thread. And this one in particular, any sim worth its salt, if it has sysmon enabled, is looking for these like a hawk. And because this only happens in really rare cases. K the Cyber Guy, thank you so much for the follow, and you're very, very welcome.
So I just sent you in DM form the compiler flags that I like to use for payloads.
Ooh.
When breaking out the big guns for Nim.
I like it.
So one of those, the app equals GUI, you can change that to either console or GUI. It's kind of a Sil Charybdis situation. Like GUI doesn't show any kind of output to like a black screen or anything, but it's more sus than console. Console, you might get the black screen popped up, but it flies under the radar a little bit more.
And
but your mileage may vary.
What's going on in the background there? Actually, I'm gonna go over to my F# shell to explain that a little bit. So there's some properties of your process that those flags are setting up, right here. Yep. So if you were to do this in C# or F#, it would be like process window style hidden, which is what your GUI or console is doing. And create no window is in particular. And if you can detect processes that are getting created with these flags, and basically only Defender or like really solid EDRs can do that, but if you can detect on that, that's a tell.
So yeah, the the app one is one to play around with. Dead code elim optimize for size or speed, stack trace and line trace off. That makes it really fast. So if you optimize for speed, and you keep a stack trace and line trace, basically like if your program throws exceptions and things break and it just like completely dies, you're gonna get better error messages if you keep those on. But if you want it to be much faster, actually Orbital Gun, if he's still in the audience right now, when I wrote Shadow Steel, he came through and like did the thing that like if you actually know how to program you do, which is like write it to be really good.
Yeah.
And he was like, hey, let me show you some tricks. So he like made it, he took it out of like I swear to God, I was in like exponential time at one point, and he like took it out of that and then made it a lot more simple, and then he was like, and optimize with these flags, and it should be super fast, and it did a brute force of the volume shadow copies in like an instant. So I was like, whoa, that's so cool. Whereas before it was taking like, it was pretty standard, like try something fail, and it was clipping along. But like when he optimized it and then threw those flags in there, it was just like, it was completely instant. So yeah, that was huge shout out to him for doing that, for writing, both refactoring the code and teaching me about optimizing for speed. Awesome tips.
Yeah. Nicely done, Orbital. So I was really kind of hoping that this was going to get detected. I'm very sad that it didn't. Because remember, I am technically a blue teamer.
Yeah.
But very technically at this point. But that being said, I do want to show you just like the really easy, what are we detecting with? Just Defender, Al. I want to show you the really easy recipe, single ingredient that you can use to obscure your shellcode in a Nim wrapper, and this will get past at least some name brand EDRs that I've tested them against. So, and again,
one weird tip. Defenders hate him for this one weird tip.
I can't, cook, but I can definitely do this. I'm lucky to make a cup of tea without sending myself to the hospital. So here's what we're gonna do. We're not gonna change much, but we are going to change the way that the shellcode is stored, because what we want to think about just for a moment is the kind of stuff that that Defender and other endpoint detection and response tools are doing. What are they doing? They are analyzing the code, and they're doing a couple things. Obviously, they're looking for straight up hashes, right? Signatures. So if you use known malware, right, you download that, you're going to get hit. Don't do that. The reason why your meterpreter payload is getting detected is because the sequence of bytes that makes up the meterpreter shellcode is within the binary somewhere. And if it isn't completely obfuscated, that series of bytes is going to trigger one of the detections. There you go, Al.
I gotcha.
Yeah, thanks. Is going to trigger one of the detections that it has. Remember that if a thing is just on the system, right, it's all it has is the nature of the file to deal with. Right? It can't necessarily look at in real time the API calls that it's making. So there are some things though that will trigger it. So just real quickly, since I'm thinking about this, I'm going to take my scripts. I guess it's just Cutter week here on this stream. And we're going to open Nim-interpreter in Cutter. So what does this look like in disassembly?
I was doing this earlier. I want to bring up a couple things after you've shown what you're about to show, but
okay.
I was doing this with another binary. I got some things I noticed.
Okay, so the first thing is we're just going to look at strings, right? It's the easiest possible bit of malware analysis. And we're going to just quickly God, there's so many of them. But one of them should be right there. So even by using create remote thread, there should be a detection for that. That's one. And good EDRs are going to do this, although not all of them do. In addition to that, right, obviously you're going to have the shellcode somewhere in here in sequence, and if that's in there, then it's going to get detected. Husky, what did you want to say about this?
So two very interesting things about Nim compiled executables when looked at from an RE perspective in a decompiler. Go find the main method or the main function. See if you can find it, because it might be the same. So there, from what I found when I loaded a Nim binary into Ghidra that I was working on, there are like 3 main methods. It's very strange. There's like Nim main, there's Nim main wrapper, and then there's main, like true main.
Well,
so
I actually am curious. There's no entry 0. There
is no entry 0, right? So that's one. And then there are a couple different. Yeah. So check it out. Nim main module.
And then sim.main. And nim main.
Yeah, we've got Nim main inner. There
Call
we go. That's
nim
the other
main.
one.
So
yes. So it goes through like 3 iterations of going
what
through. So
happening?
it's like a Matryoshka doll situation. So I don't know. Like, this is my like tinfoil hat theory that like one of the reasons why EDRs are, I don't think, like equipped to understand this is because of how many different conventions it undermines by having you walk through a couple different steps to get to your main method, right? So I have basically nothing to back that up, but that was one thing I observed when doing this. The other thing I observed, I don't know if Cutter has a place where you can go to look at the import address table. Do you know if you can pull that up?
That's a good question. I don't.
So usually you'll load a portable executable into something like PEView.
Right.
And right in the structure of a portable executable, there's a section of bytes that is designated per the kind of like how portable executables are set up to be the import address table. So everything that's being imported from other places in the operating system is set in that IAT.
Is that sort of like a GOT or a PLT and an ELF?
I'm actually not. I'm more versed in Windows than I am in Linux, so I'm
Oh,
actually
no.
not sure. But it sounds like it's the exact. Yeah, I know. I'm
So-
I'm a weirdo.
No. It's just funny to me that it's like we're speaking two different dialects of the same thing. Yes.
Yeah.
So
It
a
must be the
procedure
same thing, yeah.
a procedure linkage table and a global offset table are basically
Yep.
the relationships
Exactly.
to your imports inside of your executable.
Yes. So Nim allocates and resolves those imports at runtime, not
Whoa.
at compilation time. So check it out, Tag. If you saw the string of create remote thread, that's one thing. But if you went to the import address table in a C compiled binary, you would see create remote thread clear as day. It would be right there in the import address table.
Yeah.
And you would say, that is evil, kill it. Not the case with Nim binaries. You get two major imports in that table. Get load library and get proc address. And between those two, that resolves every other import that you need to run your binary. That is insane from an OPSEC perspective. That is like hello world coded in C would import more or would have more imports in the IAT than what you see in Nim when you open it up in a like a binary disassembler.
That's crazy.
It's absolutely bonkers to think that like you can load it with like create remote thread and like download from URL and like all these really suspicious imports.
So
it'll sail right by static analysis.
To your point, Cutter does have this. They call it symbols, right? And and that's kind of their term to do it in whether it's an ELF or a PE.
Mm-hmm.
And so in symbols, right, it'll have your address, what type it is, and anything here. And indeed, if I look for thread, the only thing I have
get current thread ID.
Current thread ID, but
and you've
inject
got
create remote thread. If I change the function name in my
exactly.
in
That's
my
the
code,
name that you
that's
called it in the code. Yeah. It's so devious. Oh my god.
So Oreo Byte asks, can Nim compile Windows service binaries? Yeah, I don't see why. Like anything you write can be registered with reg svr 32, right? So yes.
Yep. It's crazy.
And it can
Absolutely
you can compile to DLL if you want to.
Yes, you can do that as well.
So wow, okay. So from a detection standpoint, from a malware analysis standpoint, first of all, we could change this and fix that issue.
Yeah, you could call that banana hammock.
Exactly.
And it would go away.
And that really makes it difficult for unless you're doing this manually, any sort of automated detection to pull out what's evil in this. Now, okay, let's pretend that Defender did catch our who cares interpreter binary because it should have. But let's say we wanted to clean this up a little bit. One trick that I figured out, which is super naive, honestly, is we're going to get rid of this shellcode array as written. What we put back is still going to be quite large, but not quite that large.
Al, to your point about CS donut and wrapping it with a Nim payload, that's exactly what I've been doing. And it's been working like a charm, man. Not with Cobalt Strike, but yeah, same general idea.
Okay, so what we're gonna do with our shellcode is a cute trick. We're gonna go first over to our. Oh, this is our shell. We'll just kill that. We don't need it running anymore. We'll go back over to our shellcode here, and we're going to yank all of it, and then we're going to go to our old pal CyberChef. And again, this is going to sound dumb, but like
I think I know.
I think I know what's but don't overthink it, right? Like when I first tried it, I was like, this can't possibly work. Yeah, it does. And we're going to just base 64 encode this thing. And we're going to reverse it. Because they actually, good detections will have the base 64 encodings of a lot of interpreter stuff. But if you reverse it, then they don't. So,
Nice.
we're going to take our reversed base 64.
Reverse.
Yeah, and then we're going to take that and put it into this SC variable.
Yep, I got you.
And did it actually paste everything, or did it just...
I think you're fine. I think it's just like VS Code is like you're on your own with that one, man.
That line's too long. Stop that.
Yeah. If you save and it runs the nim check, yeah. Oh well.
No,
well, you don't have a shellcode variable now. No, you're good. You're fine.
No, it's saying tokenization is skipped, which is correct.
So it's yelling at you for inject create remote thread no shellcode variable, but you just supplanted that with SC. So we'll fix that here in a second.
Oh, actually, I'm looking at this. I didn't even reverse it in my samples. So, just kidding. Although that is something else that you could do. But yeah, even with just a straight base 64 encode, so let me delete this and re-add it. There we go. Okay, so after that, we're going to use a couple of libraries. I believe that I need to import base 64.
Base 64, yep, it's super simple. Yep.
And I'm also, you're gonna like this, import CQtils.
Ooh. Oh baby. Are we about to get
this
functional in here?
Yeah. This is
we
where
have to try to function.
This is where my inner lambda shows up. So what we're gonna do is, this is the shellcode. We're gonna say var sc seek, and we're gonna do base64.decode the shellcode, and then because it has these commas in here, right? This is a string now. I'm gonna split it on a comma, which gives us a sequence of these strings, 0x whatever, right?
Yep.
So they're not yet bytes. To get them into bytes, I'm going to use map and create an anonymous proc. This is the Nim version of a lambda, where we do proc. We say that the hex code coming in is a string. We have to type it, and then we say, and it returns a string. Then we say equals, and then what do? We say strip h. So we're getting rid of any line or like endpoints on it, just to keep it nice and clean. And then we map, because I believe some of these end up getting encoded with line breaks, the way CyberChef did it. So we're just keeping it clean there. Then we do another map. So at this point, we've taken the shellcode string, we've split it into a sequence of smaller strings that look like this, 0x and then whatever the shellcode is, or whatever the hex code is. Then we got rid of any line breaks that happen to be in there. Then we're going to map it to another proc, which is, I kid you not, just parse hex int. And I think we might need to import something else. I think that's in string utils.
Nim,
So
you've done it again.
import str-utils. That should give us parse hex int. And I kid you not, it just gives,
Oh
if you
my
give it
God.
a string representation of a hex value, it gives you the actual hex as a byte. So that's like it. Oh no, one more thing to do. So once we have this, we have this gives us the integer, but it takes it from the string representation of the hex. Now, this is why I didn't write it as shellcode yet. Var shellcode is going to be an array, and this is the part that's a little bit funky. We know, because of what we already did to create the payload, how large the array is. Remember that in Nim, arrays are fixed size, so you gotta know it going in. And by the way, if we're going to try to do this with a list, you cannot do it. You can't convert a list of unknown, or a sequence of unknown size to an array at compile time. It'll yell at you because it's not memory safe. So we have to create an array of known size first. That's okay. We know the size. and we know that it's going to be of type byte. With that, then we're going to do a little bit of iterative work for S in 0 to 2,261, right? The indices that we care about.
Yeah.
And this actually threw me for a loop for a while. That the ranges in Nim are inclusive of the end,
Yep.
whereas in Python they are not.
I for the DNS exfil, I'll tell you the story about that, because I kept tripping over the off by one on that one, but we'll get to that in a second.
So we're basically typecasting here for each of those. They're saying the shell code at index S is going to be the byte version of whatever we have in this SC sequence, which we've already created. Having done so, we have now successfully obfuscated our meterpreter payload such that most... Al's like, what? This changes everything.
I was losing it over there. Yeah, I'm just quietly taking screenshots over here. Don't mind me. The way your brain works, like the fact that you can look at this canvas and just be like, oh, we're gonna do a couple maps, and it just like, that's what I aspire to get to at some point. Because I would have solved this with a sledgehammer, and you are using like a scalpel right now. It's amazing.
So there are 3 things that got me to be the like this. Thing 1 was taking that Haskell course that I told you about. I'm not kidding. It like changed my programming life, and it's free from edX. 2, doing stuff like Exorcism and Code Wars and looking at the most elegant solutions. They all ended up looking sort of like this. And actually, oh yeah, we'll do some links. edX. There it is. So this is the edX course. Taught by Eric Meyer, right? Yeah, this guy's a legend. And so that was 1. 2 was doing things like Exorcism and Code Wars, and looking at the elegant solutions. And 3 was, I hate to say it, but learning Rust. Rust is so annoying, because it has this ML pedigree. And ML, not machine learning, but like the language ML. That it is functional in its DNA. And if you learn how to take advantage of the functional parts of Rust, all your code gets so much cleaner. Yes, a hacker, 3 things that actively hurt to do. My brain has been shaped. I went to the mountain.
That's like you took a long walk in the desert.
Trained with sacred men.
Yeah.
CQ Dev, thank you so much for the raid.
It's like, tell me the truth. Like, I'm not afraid to hear it. And then, like, those 3 things are just printed on the meme on the other side.
Don't forget that, you know, I'm a student of, like, Kung Fu, like, actual Chinese martial arts. So enduring pain to gain skill is something that I'm deeply familiar with, and there's no other way to do it.
That's like when you just painted that solution like you were looking at a canvas right there. Like, that was something to behold. So like, that's the kind of stuff when you know the way of how to solve that with map and functional programming syntax, like, you'll see it in every solution that you start to go. So like, yeah, that's I understand that that's the end state. I just have not waxed on, waxed off enough to like get to that point. So
now,
yeah.
Al had a question somewhere back up here. I'm trying to see. Can you add Nim to Cobalt Strike?
Oh, that's a good question.
Well, so yes, you can. So actually, Al, I think I talked a little bit about this. Oh, that's what it was. The map explanation. Yeah. Okay, so let's talk about maps very, very quickly. They're one of my favorite things. So, and Oreo Byte, I will answer the Cobalt Strike question too. But so maps. Think about all of the work that you've done with for loops, and imagine you could do it in a single move. That is possible when maps, it is possible when your target, the thing you're trying to make at the end, is the same shape and type as the thing you're coming from. Yes, it works just like Python's map, right? So what we're doing is we're taking a function and we're applying it to every element in a sequence. The result being a sequence of the same size with values where that function was applied to each member. So what we're doing here, imagine that this proc was a lambda. That's what we're doing. This proc is an anonymous function. JavaScript developers, all one of you who's out there, that's the deal, right? Where we're creating an anonymous function, we're passing in each element in turn, and then we're just applying whatever that anonymous function is. It happens to be strip. As a matter of fact, I'm pretty sure I can do this even cleaner. I bet this works. I think I just can map the function strip. I don't need the anonymous function because it's a single argument. It might not work that way. Type mismatch, got seek string. No, it requires the anonymous proc. That's annoying.
Okay.
You could have done it. You could have done it that way in Python.
Well, Tag, when you make your own programming language someday, we'll implement that as a feature.
So actually, one of the things that I love about Nim is its metaprogramming capabilities. You can write your own stuff very, very simply in it. Okay, so we have obscured our interpreter payload using just a base 64 encode. Why does this work? This works because when the EDR or defender, whatever, goes to look at this thing, it doesn't have anything to grab onto. And especially if we had changed this function to not create remote thread, to your point, like it's not importing things until we get to the execution, it doesn't have anything to detect a signature on. There are no tells really whatsoever until this thing starts running. So the static analysis that EDRs will do, or even traditional antivirus will do, doesn't have anything that it can touch. And this was just a base 64 encode. We could have done whatever we wanted. We could have split it into 10 parts. We could have reversed it. We could have split it into 10 parts and reversed each part. Like, however obscure.
Nice XOR, throw an XOR.
Yeah, an XOR would be good.
Shift the bytes. Yeah, all kinds of stuff.
Precisely. So, you know, whatever your obfuscation or your encryption wants to be, hell, you could even you know, like mathematically generate an AES key and have that in there if you really wanted to go nuts. But that's it, right? So now we have a way to do an interpreter. Now, Oreo, you asked about Cobalt Strike. Same principle applies. If you get the beacon code, Mikoshi, thank you so much for the follow. If you get the beacon code from Cobalt Strike, right? You just get the shell code the same way we did with Interpreter. Yes, you can do the same thing with it. It's much smaller than the Interpreter code, so it'll be easier to work with, but you can absolutely do the same thing. All right, I think at this point we're ready to go if you want to play with the DNS stuff.
Okay. Yeah, let's go ahead and grab
Curious Jack is here. I saw that you were streaming exactly the same time that I was starting, but good to see you, friend.
All right, so this next little ditty is something I've been working on for my course, and to do the thing, we will need a picture of my cat. I'm not even kidding. So Tag, I sent you in DM that picture.
Okay.
So you'll need to grab that and throw it right onto your desktop.
And we're doing this in the lab, right?
Yes, we'll want to be doing this in the lab.
All right, so I'm also I'm putting the DNS exfil.cosmo.zip down in there. And
nice. You can throw the whole thing right onto Flare, and then we can move it around from there. Because you will need to. It's just the raw source code. You'll need to, or the source code. You'll need to compile it. So.
And is cosmo.jpg the correct name for the file?
Yep, that is the correct name of the file. Just throw him right on your desktop, and you should be okay. Okay, fantastic. If you're wondering why I'm doing this is kind of a keying mechanism. I'm trying to be responsible. I'm trying to be responsible here. And as a red teamer who is trying to teach malware analysis, I'm not naive to the fact that if you put malware out into the world, people are going to use it for malfeasance. So the idea is that I've designed a lot of the malware. I've designed all of the malware that I've written for the course in such a way that it reduces the amount of damage it can do. One of the ways, not all of them do this, but to the extent that I can make them do this, one of the ways is that any of the data that's exfilled is going to target Cosmo.jpg. So for the, we'll see a very good example of this. We're about to DNS exfiltrate Cosmo right off of the endpoint. So in other words, the NIM, all that the student of the course ever gets is the compiled binary. Just like if you're a malware analyst, you're not going to have the source code available. And all they can do is use it to steal Cosmo off of the endpoint in their lab. They're not going to be able to. Now, some of them are like reverse shells, bind shells. Obviously, there's a little bit of danger there. But like, if you're going to make a reverse shell or a bind shell, you have MSF Venom. Like, there's a, you know, it's I'm not too worried about that. But there's other stuff. I'm not going to give it away because I want people to be, you know, kind of excited. And I don't want to spoil what else is in the labs. But there are some very interesting malware samples in there that will target Cosmos specifically. So
now, actually, Husky, let's let's log roll a little bit. You're making this malware course. On what is it? Is this kind of an internal thing? Is this going to be widely available? If people wanted to take it, what platform should we be watching for?
Yeah, so I'm now aiming for a release date at the end of October, and it's going to be on TCM Academy. So that's the Cyber Mentors
that's
TCM
amazing.
Academy platform. So yeah, so it's the first, to my knowledge, unless somebody like scoops me like at the last minute here, this is going to be the first blue course really available on TCM Academy. So, and I think it's kind of unique in the sense that I'm not like, I mean, I was a professional blue teamer, but my current profession is on the red side, right? So I'm merging kind of two skill sets that I love, right? And I'm writing a malware analysis course from the perspective of somebody that writes malware on a day-to-day basis. So that is the idea. That's kind of the pitch, is that I have, you know, a lot of experience in you know, ripping these binaries apart and constructing them from the ground up. So yeah, I'm gonna teach you guys how to examine these binaries from. If you've never even picked up a binary, if you're afraid of handling malware, like like I was at one point, saying, how am I going to handle this stuff so that it's not that it's not risking my operating system, my physical operating system? I teach all of that stuff.
That's
and
rad
then
as hell.
on Saturday, I'm gonna be hanging out on this stream again, and we're gonna do one of the binaries, reverse engineering from start to finish, hopefully. That one of the challenge binaries that I'm putting in the course.
Yep, very excited for that. Don't miss that.
So,
That's
yeah.
going to be Saturday, 10 a.m. Pacific.
Yep.
We're going to have another guest stream. It's guest week here.
Woo!
At Tagger
Crossover
Tech.
stream.
Yeah, it's
what is this,
amazing.
a crossover episode? All right, so let's DNS exfil Cosmo. Let's grab the source code that we got there, and you guys are all going to see the source code is not available to the students because like it kind of defeats the purpose to do reverse engineering if you have the source code. But you guys are going to get a sneak peek behind the curtain of how actually awful I am at doing this stuff. But it doesn't matter because not all malware not all malware authors are like computer science majors with PhDs. Like, they're doing this stuff fast and loose, and they're writing this stuff just to be purely not functional in the functional programming sense, but functional in the does it steal data and does it do so correctly. So you're going to see exactly how kind of hacky this stuff comes across. But there's a bit of an elegance to that, I think.
Oh, absolutely.
So let's do it. All right. So
quick bit of admin here. First of all, Orbital, thank you so much for the gift subs to Jeff Kang, Cinder Remedy, Perryman, Fox4N, and GoPro. Thank you so much for the gifts to A Hacker, Curious, Jack. Your generosity is much appreciated. All right. Let's do it. So I have brought this into our nice VS Code editor with the sweet syntax highlighting.
Yes. All right. So the commented code block up at the top there is a, I think I ripped that out of Nishang. And so Nishang has a, it's an exfil PowerShell script. Excuse me. And so the idea is like, okay, I don't really know the programmatics behind DNS exfiltrating when I sit down to write this stuff, but I do know roughly how it works, and I do know where to find examples of it. So let's take an example, and like they say, I think Oscar Wilde said this, like, good artists will borrow, but great artists will steal.
Yes.
And of course, if you just gotta make sure you give credit where credit's due. So this is coming out of Nishang, but that PowerShell block up there, is the general approach to how I was coding this malware. So all right, so let's take a scroll down. We set up a couple global variables. and I throw my domain name with a leading dot there and a chunk size of 62.
Okay.
So let me ask you this. For a DNS record in the subdomain field, what is the maximum amount of characters that are allowed in the subdomain field?
Crap. I want to say 255.
Negative. 63.
Is it 63? Okay.
63 are allowed in the subdomain field. And there are, and this is just URL safe encoding in general, there are really three characters that are going to bork your existence when it comes to URLs. What are those?
Sorry, I was distracted by a question. OreoByte, 64. We're at DNS. We're not even talking about IPv6.
Yeah.
So don't worry about the IP address space at this moment. We're just talking about the DNS query.
And you'll see why. You barely even need to invoke IP in this at all. The authoritative name server variable you see there does have an IP address, but if you do this in the real world, you might not even need that.
Right.
So the three characters that are going to trip up your exfiltration.
So, null bytes.
Okay, yeah, sure, maybe 4 then, I guess.
Carriage returns, line feeds.
Well, so I'm thinking, think like URL encoding.
Oh, okay. So spaces, right?
Spaces are, yeah, maybe that's one of them. But all right. So here, I'll set it up. When you pull data out of Cosmo.jpg, right?
Mm-hmm.
You're gonna want to handle it in base64, right?
Yes.
So base64 has a URL safe schema as well.
Mm-hmm.
So the base64 URL schema is going to replace plus signs with dashes, maybe, backslashes with underscores, I believe, and then there might be one more replacement. But the other thing that's really going to bork things up is the equal sign. So if you account for those three things, you should be able to base64 encode and then use that as a DNS subdomain, right?
Interesting.
Now,
okay.
Check out. Look at line 46.
Let B64 equals encode content safe equals true. Wait, what?
Safe equals true. I molded for so long because I was like, oh god, I got to do like format strings. Okay, here we go. Equals format replace with a thing. Okay, plus signs. Do the and then I updated. I like went to the documentation. I'm like, there's got to be a better way to do this. And I saw that safe equals true. And I started using it, but it wasn't working. I went to the Nim Discord, and I'm like, am I losing my mind? And they're like, oh, yeah, your Nim needs to be updated. Just update to the version, and that's in the new procedure. And I'm like, oh, my God.
Incredible.
So that was hurdle number 1, right?
Yeah.
Hurdle number 2... And I see string 1 hello. That was just a test, so that's actually just a dead string. It doesn't need to be in there. Okay. Hurdle number 2 was the query and chunk size. So the queries and chunk size. So I was running into off by ones the whole time writing this because of that array, how the upper bound of the array is including. So I was doing base64 length divided by 63. 63 means that the block of base64 URL safe text that was being DNS exfiltrated was just a little bit too long. And so when that DNS exfil went through, it was like, oops, nope, can't, like, per the RFC, we will not allow this to be a DNS text record. And it just kept it. Yeah, it wasn't really working. But the rest of this, if we step through the code here, the rest of this is very straightforward. You basically start at 0. You take a chunk size of 63, and you increment the start bytes and the end bytes per the chunk size, right? So there's probably a less hacky way to do that. That looks good to me. You handle the end condition there, which means that if your final bytes, if your start bytes, or if your end byte is over the file size limit, so you can take the file size from the start, right? You'll say it'll never go past this length. And if your final bytes are over that, you'll just take the last part, because if you try to take any more than that, it'll say, oh, we're reading from a place in the file that doesn't exist, and then it'll throw an exception.
Got it. Okay.
So So you do some quick calculations like that. You start out with the queries by dividing the chunk size against the file size.
Yes.
And then you decrement those queries every single time. Okay, now what do you do with those queries? You add them to a sequence. So
Here.
instead of staying in cubic time or whatever I was in at that point, geez, you will go down to for query and query seek. Command equals, and then there may be a way to do this from an API call or something like that. I'm using straight up NSLOOKUP, like very down and dirty. Query text record, and then we've got these lovely little non-formatting formatting strings here.
You've got me curious now to see if there is a Nim DNS library.
There might very well be. I didn't think to look at that. But yeah, it seems like everything we've tried at this point, everything we've thought of at this point, Nim's like, yep, here it is.
Is there a thing?
Here's a bouquet of flowers.
Let's see.
So,
nimble.directory. Let's just look for DNS.
Yeah, let's do like DNS
hey!
something. DNS client. Okay, great. So, love it. Oh
and what
God.
is it? Client does send query. Yeah. Okay.
Send and an argument for text record. Awesome. Oh my God. All right, so we could refactor
I feel like
this
this
tonight
is a
if we
little
wanted
tongue-in-cheek. I feel like they know what they're doing here.
Yeah, they know what they're doing. Oh boy. So, all right. So for those in the audience, when you take your sequence of base64 encoded data and you put that in a for loop as the end of that command, you have NSLOOKUP, which is a built-in binary in the Windows operating system. You'll say we're going to look up a text record. You're going to send the query, which if you scroll up a little bit, the subdomain, if you go all the way up to basically at the globals, the subdomain is going to be at the front of domain name. The middle domain, Cosmo for Boots Emporium.local. I keep all of the URLs to look as realistic in air quotes, because Cosmo for Boots Emporium maybe not so much. I try to keep them realistic. A lot of the other URLs in the course are like they look like EC2 instances, so like they just look like AWS boxes. But every single one of them has .local at the end. Why do I do that? Does anybody know why I do that?
Is it a safety measure?
Remember I said that I'm doing this to be safe.
Yeah, it's a safety measure.
Yes. I do that because local is it's similar to like a private IP address. It can be assigned in a local area network, but it cannot be registered in the greater DNS scheme.
Right.
So the idea is that, like I said, when you put malware out there, there's a chance, unless you mitigate that people will use this, and then your name is on it, and you maybe don't want that. So all of the URLs in the course are designed to be those local addresses.
Very cool.
Does that completely negate the possibility that there's somebody who registers something in their host file called Cosmo for Boots Emporium? No, of course it doesn't. Same thing with that 10.10. Is it possible that somebody out there has a private IP registered host at 10.10.1.179? It's possible, right? But like, the idea was to mitigate the risk as much as possible.
For sure.
In any case,
a couple housekeeping things. First, I gotta say thank you to Project DP for the subs for ETH0 Ghost, Destroy Worlds, and Oreo Byte, and GoPro coming in once again for the sub to Site Zero. Also, Al, you're asking if you did this on a live network with Splunk listening, Splunk would actually have an aneurysm with all the alerts. You would be surprised. No, I don't think it would.
Well, you would get a ton of, even Windows in its base configuration is going to pick up DNS requests as part of like the. I guess it depends on how
you would be shocked to discover what is doing DNS without you knowing it. Here's something that everyone should do at one point in their if they're interested in any kind of analysis. Proxy your whole system. And by the way, when I say that, I don't mean just like set your network connection proxy, like your global proxy in Windows, because that doesn't do it. There are applications on your Windows system that use a separate network stack that don't honor that proxy. If you want to proxy your whole system, you have to use the netsh command to set up an advanced firewall rule. Send everything to your own, like a custom network interface that you set up, and then send that off to a proxy. I'll do that on some session one day, but yeah, it's pretty cool. But the thing is, you would be amazed what is doing DNS without you knowing about it. And here's the other part about stuff. One of the things I had to learn doing this job is that there are a lot of defensive security tools that look like malware, or administrative tools that look like malware, SCCM. If you look at some of the things and what they do, like SCCM just like creates arbitrary PowerShell scripts and runs them as system. So like if you're looking at that as a defender and you don't know what you're looking at, your hair sets on fire. So Al, to your point, there are tools that actually do base 64 encoded DNS by default. One of them is Sophos. Sophos has a feature called for web protection that creates base 64 encoded queries to domains, subdomains in the domain sophosxl.net. What it's doing is before it allows your browser to actually go to where you're supposed to go, it preempts you, sends the base 64 encoded version of your DNS query itself to its own DNS server with that subdomain as the data, and then determines whether that matches one of its blocks on its block list. And if you have this enabled, is absolutely, it looks like you're infected with a botnet. But it turns out it's just Sophos, and it's not the only tool that does that. But just like you cannot imagine the amount of noise that legitimate tools actually make in a full-out enterprise environment. It's bananas. And so yes, should your SIM actually be detecting on stuff like this? Totally. Will it? I mean, we're talking about an enterprise with an actual security team that's monitoring a SIM. That doesn't exist everywhere.
So I'm just looking at this should be fine. So to really drive this home, let's compile this bad boy.
Yeah.
First thing that you probably want to do, because you have control of the source code,
change
your authoritative name server
to the Flare VM, because we're going to use FakeNet,
to your Flare VM, and you can just have it run right on your Flare VM. We can basically trick it. There is, inside of that Cosmo DNS zip file that I gave you, there is a little packaged Python DNS server lookalike, I would say.
Yes.
And we can fire that thing up, and we can see what this looks like on the wire. I guess you could do two things here. First, we can fire up FakeNet NG. And this is actually like a preview of what we're going to be doing on Saturday, and a preview of the course. So let's fire up FakeNet NG.
Okay. God, where
so
is that thing?
Yeah, if you go to Flare, you can actually go to the command shell and just type in FakeNet.
Tell me about that, because I actually haven't done that too much.
Yeah, so go ahead and just FakeNet, and then maybe .exe if you want to do that. All right, this bad boy is going to fire up. So, FakeNet, here we go. Much like if you're familiar with the program inetsim. Are you familiar with inetsim?
Yes.
So, whereas inetsim you might have on another box, and you can use that as your default gateway, or if you're really crafty, you can set it up to be its own kind of internet simulator. FakeNet NG is basically one-stop shop to set this up and run it like it's inetsim, right on the box, right? So now we have a DNS server running. We've got handlers for HTTP and HTTPS requests. We've got all this stuff, and it's saving everything to a PCAP in the FakeNet logs directory, which is somewhere. I don't quite remember where.
This is great.
Yeah, you see like HTTP listener 80. So go ahead and let's compile, or really just even open up Chrome and go to like google.com or something like that. It does something similar to inetsim, where it will tell you, oh, this is the default FakeNet NG page, and had there been an actual HTTP request or a DNS request or something like that, it would have been handled at this point. And it shows you the process that's making the request and maybe some other information of where it's going.
Yeah.
Super, super valuable. I don't think it supplants inetsim. Sometimes you want one, sometimes you want the other. Sometimes you want it to be on the host so that you can capture kind of the more host-based logs, like the process and the IP associated with it. Sometimes I like having it offline, just in inetsim on another box. I don't know. It doesn't supplant it. It's just in to help out as well.
Hey, Bono's Tech, thank you so much for the raid. welcome to the viewers from Bono's Tech. Really appreciate you stopping by.
Hello.
Yes, Al, there is the DNS cat. I think one of the things that, this is going to evade quite a few signatures by, taking the time to write the code. That's like the trick, right, to getting away with stuff is take the time to write the code yourself. And then it won't match signatures. Yep. Okay, so let's compile this guy, right? We have cosmodns.nim.
I always put the compile flags at the top. So like I said, that was my compile for speed. So you can grab that.
Love it.
And then it just changed the file name, of course.
Right. All right.
Now the Cosmo file is a hefty file, unlike Cosmo the cat, who is not a hefty cat. He's a fine boy. But the file is like a few megs, so it will take
megs.
Yeah.
Oh,
so it will
adorable. Rust programmers, let's talk about how large our binaries are.
So yeah, the exfil goes pretty fast, but even still, it takes a while on this one. So we'll go ahead and see how this goes. Now, first thing we can do is take a look at the FakeNet NG, and I don't know if it'll like handle all the DNS requests, but we'll see how it happens. Because I think I switched over to the Python server to get the actual text records, so I could reassemble the data.
All right, so we just want to fire up Cosmo DNS.
Fire that thing up and take a look. Yep, and take a look in the background.
Okay. Get over here. Nothing happened.
Nothing? Wait, 1 second. Dude. Source, DNS exfil Cosmo. I don't remember if there was another. No, it should have been fine. Huh.
Is there anything with the pathing? Do I need to run it from the desktop? Should
I grab it from the home directory.
Yeah, home directory. Yeah, that should be good.
Yeah.
Let me run it from the command line and see if we
go.
Get
Yeah, go ahead and run from the command line.
We have an exception index issue.
Do we have?
Are we debugging? Okay, so
let me think. Yeah,
that was in.
So we might have hit the
23364
Have we hit the off by 1?
Looks
I think
like...
I thought I fixed that. Oh my goodness.
It's cool. So
go up to. Oh man. var queries. No, because that's the number of queries. We need the.
Is it the remainder?
Might be the remainder.
Yeah. So the mod isn't it? Wouldn't the mod still be by 63? The remainder is how many what?
So the remainder is after all of the, I think the last round of bytes. What you want is the difference between that final position of the start and the end of the file, and that's how many bytes you take. So I'm just looking in my repo over here because I thought I pushed this to the maldev repo. DNS exfil Cosmo. Let me see if I debugged it over here. Chunk size is 62. Div by 62. Mod by 62.
Mm-hmm.
Yeah, we're 1 for 1 over here. Everything looks okay over here. Well, that's disappointing. We must, yeah. We'll throw a because what was it said it's off by the array of what is off by 1?
Exception index 2336488, not in 0 to 2336487.
Okay,
so
0 to
is
that's
1.
Yes, so that's final bytes. So exception index would be the final bytes either add 1 to the final bytes or remove 1 from the Let me
Start
think
byte
here.
Plus remainder. That's why I'm saying, like, I feel like remainder should be...
Yeah, you know what? Minus 1 from remainder.
-1?
Or, well...
Because this range, if n byte is less than file size limit, so, hold a second. Be stuck by final bytes, creation, and creation. So, the problem is that it's trying to add one more than...
Yes. And so think the final bytes...
Final bytes has to go up by 1. Right?
And actually, yes. So, yeah, try that. But I think it's actually even sooner because that's in the final size limit block, right? So before you even hit that if block, go back to while queries is not 0. That's, I think, where it's tripping up because otherwise it would have
Start byte to end byte?
run. Yeah, start byte to end byte.
Chunk size plus 1, maybe?
Let's give it a shot. Let's see if chunk size plus 1.
All right.
Now this is that chill code hacking that we came for.
Yeah,
All right.
for real.
Debugging time.
Okay.
Man, this is disappointing. I thought I fixed this in the code.
Hey.
But yeah, this is something I've been tripping over during the development of this.
Welcome to every time I try to write something. Yeah, copy to replace. Okay.
All right, and from the command line, because we'll get the output.
Poop.
Now we're to... Oh, it's the same.
Same error. So we didn't find it.
You're deriving that number, that second number on the right, from length of base 64. So...
The end byte?
Well, not the end byte, but the...
All of your code works first try. Great, Al. Well, we can't all be you.
Not all of us have the forces of dark on our side at all times. Because is it? Because it's like you're trying to stuff an array into, or well, you're trying to stuff a. Rats. Well.
Okay. Here's something that I would do at this point. If I want to know exactly where this is going wrong, I'm going to start adding some echoes here just to see what happens.
I took all the echoes out after I got this to work before it stopped working again. No, I've been had.
Starting to build queries, right?
Yeah.
Okay. Hackerman, thank you so much for the follow.
We are so doing it live right now. This is
great. This is great.
Paid for my whole seat, but I only need the edge.
All right. So we're starting to build queries, and then down in here.
I think we're not even hitting that if block because that is just at the end of after it's run through and it gets to the final set of bytes because that final set's not going to be a 63, a set of 63. So
Okay.
yeah, let's start there and see if we even hit either of those print statements.
Okay, so copying this. We got a question in the Python debugging technique print statements. You know what, Al? It's been the debugging technique since COBOL and Fortran. And except for actually like taking moths out, like Admiral Grace Hopper.
How many attendees for the course? MSRP on the TCM Academy courses is like I think $30.
That's right. I think that's right.
And
but
yeah,
Joe
and they go on
Heath
sale.
they've been doing crazy giveaways all the time. Like if you buy it at full price, it's because you really wanted to. But also you should because it's a great outfit.
I'm probably going to set aside some of my own money just to like, hey, like free course, because I can't really control the price when I put it on the platform. Like that's out of my control. But I could like buy my own course and give it to people if I wanted to. So I might do something like that. Okay, so no, that's fine actually because look back at
Wait.
Yeah, because got to final bytes ran. Did we get anything from the DNS side of the house?
It doesn't look like it. I'm not seeing Cosmo or Fur Boots anywhere. Hey, Security Live, thank you so much for the sub.
So why don't we break open the DNS Python server and see if we get a better result out of that? So go find the zip file that I sent you.
Got it.
And and let's break out that DNS server. I just found this. Yeah, just fire it up. I think there's like an argument you need to pass to it. But the usage is in the line. For those watching, this is something I found on GitHub, and it's just a very basic Python server to handle incoming DNS requests.
So do we
so
want
it
to kill
acts
FakeNet
like-
for this?
Yeah, we do want to kill FakeNet. FakeNet will commandeer your entire like networking stack if you let it. So you've got to kill it if you want to get any meaningful networking done. So then if you throw that, that will give you the usage, and then I think you just need to specify.
Oh, for the love of God!
What? Oh, DNS lib. Okay. Do that real quick, and then we'll see if we can get this to kick off. I'm so miffed. I'm about to like fire it up in my own Flare lab and see if it works or not. So anticlimactic, but I guess that's kind of the name of the game sometimes. Oh,
Did we break something?
you may want to reset your network stack given that we used FakeNet. So I would just like disable your NIC and then re-enable it from the networking thing.
Yes.
Let me see. I'm gonna fire this thing up over in my lab.
Do I not have it disable? This stupid new thing. Did not pray the demo guards hard enough. Literally every demo I saw done at Wild West Hack and Fest was recorded because they knew better at this point.
Yeah.
But I don't know. I appreciate people doing things live. I'm okay if it goes
There's
wrong.
a certain, I don't know, there's a je ne sais quoi about like, all right, and here we go, and oh, that didn't work. It's a human thing, right?
Exactly.
And like, yeah, like you guys should see the recording sessions that I have to put in to even just get a thought to be correct on the videos I'm putting out right now for the course. Like it will be like a good 20 to 30 minutes on a single kind of idea to try to really clarify it and really get it to be like correct, right?
Oh.
So yeah,
Enough with this.
oh my God.
Oh, wait a second. Network 3 no internet, but I just gave you back your internet for network 2. Yeah, it's got the right IP address.
Oh, okay.
What did we do? Do we just want to just restart the box?
This might be Python 2, in fact. I'm trying to determine if I launched this from a Kali box that had Python 2 installed.
Wait,
you have your Kali you have your Kali box, right?
I do,
Yeah,
but are you telling me that you wrote Python 2?
No, I found this online. This is not. Is this Python 2?
No. Python that comes with Flare at this point is definitely 3.
Python is 3, but the that DNS server in the background is definitely. I'm pretty sure it's Python 2. Yeah.
No,
let's move this over to.
With,
oh yeah, okay.
I think it's
yeah, because
3.
it's weird. I didn't need to, because I got that same dependency issue.
No, the issue right now is the network stack, where DNSLib wasn't installed, and I can't resolve anything. So we're gonna just kind of reboot this machine here, and we're gonna vamp for a minute.
Cool. Meanwhile, I'm over here getting the proof of concept running to see if. All right, now I've got. So we'll do ports.
So for those of you who are just coming in, what we're doing tonight is we're writing malware in Nim, and we've gone through a couple of things already. The first thing that we did is we wrote a very simple reverse shell in Nim, and it's literally just this. Would there be interest in this? Doesn't seem like something that's enough for a Git repo, but if I made the gists, would folks be interested in these as samples? If so, I'll put them up.
For sure.
And we'll share those in the
I
Discord.
specifically want to see that shellcode obfuscation technique.
Yeah,
it's like super cool.
And so with the reverse shell, literally just creating the socket, sending some data. I give a little nice PS prompt here, just so when the netcat listener gets bytes, it knows that you're ready to go, and then you're off to the races with a PowerShell. Now, this is going to get detected by any EDR worth its salt, but it's fun to play with. Yeah, the security lab is already writing to Splunk detection rules. Now, for the Meterpreter payload, what we did was we took Marcello Salvati's basic offensive NIM sample, which gives you the shellcode in bytes and then uses create remote thread to inject it into a process. However, that because the shellcode in bytes is in a sequence that any Yara rule can find, or an EDR that's using Yara in the backend can find, to get around that, all we did was literally base64 encode the string of the comma separated byte. So like 0x whatever, comma separated. We base64 encoded that as a single string. Then, moving down here quite a bit, we use this technique to get it back out, where we base64 decode that, we split it on commas, we use strip to just make sure there are no line breaks or anything weird in there, and then we use this parse hex int function that's built into the string utils library in Nim to get the byte, or sorry, the decimal, or the integer representation from the hex string. So if you have a string that literally says like 0x 41, it'll turn into the integer representation of whatever that is. So now at this point we have a sequence of integers. Because we knew how large the shellcode was, we could create an array of that static size so compilation doesn't yell at us. We create it, we make it empty at first, and then we loop through our sequence of integers, and we create the byte from that integer in that array for each one. Now we have our shellcode back in a byte array, and we're ready to inject that into our thread. So by just doing a base64 encode of the shellcode that you get from MSF Venom, you can get around quite a lot of defenses. Thank you so much for the thank you for the follow.
So I hate to be the guy. I hate to be the guy. Are you ready for this?
What's up?
It works on my machine.
I'm so happy for you that it works on your machine. That's really neat.
Damn it.
That's cool,
I hate
man.
to be that guy. Oh, good for you. Jeez. I mean, we could like funky screen share if we wanted to, just so I could prove that I am actually a programmer and know what I'm doing.
Let's do it. Go ahead, share your screen. I'll move it over.
All right, stand by, my friends.
All right, let's meet.
This, I think people get the point anyway, though. You're stuffing subdomain, you're stuffing data into a subdomain and sending that subdomain to an authoritative name server, or your own kind of like just like bad guy server, and the data can be retrieved. Okay, so we've got where to go?
720p.
DNS
What is this rookie
Exfil
stuff?
Cosmo. We've got our good man Cosmo right there. And on the Kali box over here, I have that Python 3 DNS.py running on port 53 UDP. So fire it up, and a whole lot of stuff happens. Now you're going to see no text record available. I know it's scrolling very fast, and it's probably a little pixelated, but it says no text record available for, and it's just going crazy, right?
Yeah. I can see Cosmos for Boots Emporium. By the way, Al, yes, this will absolutely create an alert in your if you're looking for DNS scope.
So check this out. So so see the ticker tape scrolling by. It's like we're on Wall Street right now, watching the stocks go.
No, that looks legit, man. That looks fine.
Yeah, totally legit text records scrolling by. So yeah, this data, if I actually just control C this really fast, like each chunk of this data can be like, and I don't have the Python script to do this, but if you were a bad guy DNS exfilling, you'd probably have a Python script that's catching these text records and then like offloading them into a text file and just keeping that data on your physical operating system. And then you can just reassemble it from however you encoded it on the client. You're going to reassemble it when it hits the server. So all of those text records, and I guess I could probably fire it back up, and it just keeps going. All of those text records are coming off of this binary, and none of them are really resolving to anything. Like obviously, there's no host that's going to be incomprehensible.cosmos for bootsemporium.local. But that's not the point. The point is that the data is hitting the server at all. And so when the data hits the server, it can be reassembled at that point.
Now, from an operational standpoint, from a detection standpoint, this is cool if you have any degree of DNS detection. this is gonna look noisy. It really will.
Yes. Big
even
time.
if
Yep.
it's against an AWS domain or something like that, that's gonna look pretty wild. So like, I still think that there's value in using things like standard TLS or whatever, but it's a really cool technique, especially if the amount of data that you need to get off is like known, or you go low and slow, right? If you so not to
Yeah, so that would be mine's a bit fast and loose, but if you throw a nice long sleep, and like I said, don't use sleep in the main thread if you're worried about OPSEC, but if you throw a nice long wait period in there and maybe some jitter in there as well. Throw a DNS request out at midnight, and then 45 minutes later another one, and then 13 minutes later another one, and then you probably just nice and easy.
Now keep in mind that from what do the bad guys do, right? The bad guys, their dwell time, especially ransomware actors, right? It's actually gone way down. Threat Intel used to have us at saying dwell time was somewhere around 6 months after a compromise of a major organization, to actually pulling the trigger on ransomware. That's down. It was down at like 2 weeks at the beginning of 2021. We're now down to like 6 days or something like that in terms of criminal actor dwell time. Notice that I'm using the term criminal actor, not hacker, because we're doing hacking right now, and we are definitely not criminals. But hashtag hack not crime. But it's because they've tightened up their playbooks, and they're able to just move around quicker because they know what gets caught, what doesn't. But that being said, once they pull the ransomware trigger, they've already exfiltrated what they want. So as soon as they start finding crown jewels, that data is starting to leave your network piecemeal, right? So they're going to be going low and slow, and that's kind of what you need to be looking for as well. So again, you need to have your logging system, really set up well to catch that. Man, a whole lot happened tonight.
We had a good go of it, man.
This was amazing. So first of all, Husky, thank you so much for coming on and sharing your preview of the malware analysis stuff. We're going to do more of that on Saturday, and doing some Nim code with me. This was a lot of fun.
For sure.
I freaking love writing this language, and also basically doing pair programming with you. I think this worked out super well.
I wish we could have troubleshot the DNS exfil, but I'll take a look again. But what I really want to say, thank you so much for having me on. This is so much fun. Streaming is a lot of fun, turns out, guys. It's a lot of fun. But thank you very much for having me on. This is an absolute blast.
Yeah, my pleasure. So thank you everybody for hanging out. Let's see if there is anybody who's still streaming that we can send folks to. And we are, of course, using the hack list. Okay, looks like we have Hack or Game who is currently streaming, so we'll send folks there. But if you don't know about the hack list, there it is. There are a bunch of us who do security streams, and go find your favorites. Make sure that you follow them if you can, subscribe if you can. Much appreciated. Thank you so much for all the follows and the subs tonight. Really appreciate it. Oh, do I not have? There we go. So that's going to do it for tonight. Thank you so much. Until next time, friends, be good to yourselves, be good to each other, and I will see you next time.
Good night, everybody.